We are trying to give it a go. You let me know. Yeah.
Good morning, ladies and gentlemen. Thank you very much for being here and also online. My name is Maitane Berecibar. I am the head of the Battery Innovation Center at the Vrije Universiteit Brussels in the Mobile Research Group, and it is my pleasure to be here in this final event of Assured together with Aida.
Indeed, Maitane, we are very pleased to be here today in the final conference of the Assured project. We are very happy to see our project partners here on site after already quite some time. We had not the chance to meet face to face, so it's a very special moment for all of us. But also we are very happy to welcome many colleagues and fellows on the online realm. So welcome everyone to this event today. For those who still don't know about Assure, I know in the room it's totally impossible not to know about this. You are our dear colleague and partners, but perhaps online. Assured is one of the most important European Commission projects when it comes to the electrification of urban commercial fleets. And what we have done this last 5 years, we have addressed quite some questions on standardization, interoperability, battery aging, grid stability, many more that we will be presenting to you today, sharing the knowledge with you thanks to our Assured partners on site, and a couple of colleagues who will be joining us from remote. So without further delay, I think we can start with our first keynote speaker. So,
yes,
Maitane.
Thank you, Aida. It is my pleasure to introduce you to our first keynote speaker. It's Mr. Patrick Mercier-Handyside. He's coming from DG Research and Innovation, European Commission. Patrick, the floor is yours.
Muchas gracias for the introduction. Good morning, everybody. I'm very happy to be there. It's one of our first conference for some time now, I'm afraid. So it's good to see you there in the room, but also outside. So a very warm welcome from the European Commission. I'm very happy to be there also today because it is the end of a very important project for the Commission, the Assure project, which was a real flagship project for us. I would like to thank two organizations. First of all, VUB, the Free University of Brussels, and UITP for organizing this event here today, and of this nice project. I would like also to say that this project is the result of a very good cooperation on the last year between the European Commission on one side, but also the research community, the industry, within the European Green Vehicle partnerships. So in this way, we strengthen, I think, the competitiveness of the European industry in this area. In my speech here today, I would like to highlight, first of all, the challenges on the transport policy in the context of the EU Green Deal, which was launched at the beginning of the new Commission, but also the smart and sustainable mobility strategy. Secondly, I would like to say a few words about the research and innovation agenda within the new framework program Horizon Europe, on the new 2.0 partnerships, and finally, some highlights on key events and some conclusions. So first of all, what are the key challenges, especially in cities on urban mobility? First of all, we have the problem of emission quality of air, which are a growing concern in Europe, as 1/3 of the EU citizens are living in cities. And also the concentration level of pollutants are really above the illegal thresholds, and we have many days responsible from this pollution in cities. And secondly, we know that urban transport accounts for more than 23% of CO2 emission in cities. So to tackle these challenges, what is the policy context? We know that electrification of urban transport vehicles and their integration in the transport system is a privileged path to reduce such emission in our cities in Europe. This is also in line with the European Green Deal, which emphasizes that transport must become drastically less polluting by 90% compared to current levels if we are to make genuine progress in reducing emissions and to put Europe on track to be the first carbon neutral continent by 2050. Very challenging objective. We have launched also in December 2020 a very important package on sustainable and smart mobility strategy to ensure that the EU transport sector is fit for a clean, digital, and modern economy in this sector of mobility. The objectives include increasing of the uptake of zero-emission vehicles, so very links to the topic of today for this final conference of Assured, but also making sustainable alternative solutions available to the public and the businesses. So to make our goals a reality, this strategy has put together 82 initiatives in 10 key areas for action, so-called flagships, with concrete measures to be tackled in the next years. So this strategy lays the foundation for how the EU transport system can achieve its green and digital transformation and become more resilient in future crises. A few milestones that I would like to give in relation to today's events is first of all to have 100 European cities to be climate neutral by 2030, very ambitious. And we have a cities mission which is undergoing at the moment, but I will not go in detail. To have 3 million public recharging points and 1,000 hydrogen stations in Europe. And by 2050, nearly all cars, vans and buses, as well as new heavy-duty vehicles, will be zero emission. So Assured and its follow-up is really supporting this key milestone from this sustainable and smart mobility strategy. Now we'll turn to Horizon Europe, the new framework program for research innovation for the next 7 years. As you know, it includes several activities to accelerate the transition towards smart and sustainable strategy, so really supporting this policy objective coming from the Commission. There is a significant change from the past Horizon 2020 to Horizon Europe in the clustering of key activities. We are renewed activities with what we call partnerships, different type of partnerships, but I will come back to that. And also these new instruments, which is missions, planned missions. The cluster 5 on Horizon Europe, where mobility is a little bit more wider. This time is including climate, energy, and mobility. So you really see the interlink with the policy on the European Green Deal, on tackling all these challenges at the same time. Research and innovation partnerships will be a key tool to strengthen the resilience and the competitiveness of the European industry. All research activities in Horizon Europe is both carried out through collaborative research, like in the past, but also with these new and renewed partnerships. Related to road transport, we have, directly or indirectly, we have four main partnerships relating to road transport. First of all, the CCAM partnerships, where some of you are certainly involved, on connected, cooperative, and automated mobility. We have one on batteries, which is more for basic research, but also support mostly for the transport industry and for stationary application on e-mobility, but for EU. We have the clean hydrogen partnerships, mostly for heavy-duty vehicles, I would say trucks, in fact. And finally, towards zero-emission road transport, to zero, which is more the focus of today's discussion. And they will all bring together our policy ambition for a climate-neutral and environmentally friendly mobility. So the 2.0 partnership. I think most of you here in the room are involved in the discussion on all the work which has been carried out, the preparation of the SRIA, Strategic Research and Innovation Agenda, but also the discussion we have with the partnerships to prepare the topics for the different calls. These partnerships is important for the development and the deployment of zero tailpipe emission transport in Europe with a systems approach. No, it's not only the vehicle, it's a link with the recharging infrastructure and with the systems approach. It is a public-private partnerships between the Commission on one side and the industry in the other side, but all with the research community, I should say. It has a very important EC contribution of 615 million euro. So you have the double of available fund to fund these partnerships. So it's quite a substantial increase compared to the past. We have already launched first calls, 21, 22, with nearly 200 million euro, where we have a strong focus on medium-long range zero-emission heavy-duty vehicles, but also on e-buses, BRT, bus rapid transit, and also on recharging infrastructure on the integration of the grid, smart charging vehicle to the grid. Now I would like to highlight a few events that can be important to you after this Assured conference. First of all, we are co-organizing, I should say, on the 29th and 30th of March, so very soon in Brussels, the so-called conference on the result from road transport research in H 2020 project, which will take place in Brussels. And the Assured project will be also presented at that occasion, together with many other projects. So I warn you to register to this conference as well. And secondly, later in the year, from the 14th to 17th of November 2022, the European Commission is co-organizing the European Transport Research Conference, so-called TRA 2022, that will take place in Lisbon, Portugal. So it's co-organized by the Commission and the Portuguese Agency for Innovation. So to conclude my introduction, I would like to underline the following points. First of all, I think that research and innovation is vital for the green and digital future that we all want to see in Europe, but also in the world. We need to see innovative mobility solutions can be tested and deployed in real environments across Europe, like it was carried out during Assured, and when they can generate impact and serve also citizens. Thirdly, I think that Assured, and we'll see that during the discussion today, has been a successful project in that sense, and I would already like to congratulate for the great result that will be highlighted today. Through Horizon Europe, we'll make a major contribution to this collective effort, in particular to zero-emission mobility. And finally, I would like to wish you a very successful event. Thank you again.
Thank you very much, Mr. Mercier-Handesait. Thank you for this very nice keynote and the very fruitful collaboration we had between the European Commission and the Assured project. Now we go to the second keynote speaker of the day. We have Professor Van Mierlo. Professor Van Mierlo is from the Vrije Universiteit Brussels, VUB, and he is director of the MOBI Research Group. Yuri, the floor is yours.
Thank you, Maitane, for the introduction. Thank you, Patrick, for these nice words about the project. As a director of the MOBI Research Center at the Vrije Universiteit Brussels, and as a coordinator of this Assured project, I'm very happy to welcome you all here at this final event of the Assured project. I'm also happy to see you here live. Finally, we meet together, and it's not behind the screen and looking, can you hear me? Oh, you're muted. And I'm also happy that there are a lot of people following online remotely to this event. I'd like to take this opportunity to congratulate the Assured team members for their great work during 54 months, as well as to thank all the people that have interest and look online to the results of today. As we have some external participants today, I'd like to introduce in 2 lines my research center. So MOBI at the University in Brussels is a multidisciplinary team of 160 experts in the field of sustainable mobility and logistics and automotive technology. I think we can state that we are leading the state-of-the-art in electromobility as well as in socioeconomic evaluations for sustainable mobility and logistics. And sustainability is in fact a key value of my university in Brussels. And sustainability shapes many of the current challenges we are facing as a society, including the implementation of a green, efficient, and innovative urban mobility. In this context, with the ambition of achieving clean, heavy, and medium-duty urban transport, Assured brought together a complete team of key players in this field. The Assured consortium includes public transportation authorities and operators, bus, trucks, and van manufacturers, charging solution suppliers, energy providers, national and international associations, consultancies, and research centers. The close collaboration between this multidisciplinary set of players allowed the clear definition of needs from cities and public transportation operators early in the project. This way, a relevant action to guide the technical development of heavy and medium-duty vehicles and high-power fast-charging solutions was done. Such challenges were addressed through the study of the impact of fast and high-power charging on the grid stability, as well on the battery aging. And we also developed smart tools for energy management and fleet optimization with the aim to reduce the operation cost as well as the total cost of ownership. This was complemented with the development of standards and references to enable the scale-up of the interoperable fast-charging infrastructure. Assured also covered the development and the evaluation of 7 use cases, including electric buses, trucks, and light-duty vans with wireless charging. Additionally, real-life demonstrations were run in partner European cities like Barcelona, Göteborg, Osnabrück, Eindhoven, and Jaworzno. These real-life operations activities enabled the verification of the interoperable fast charging and the demonstration of the upscaling and optimization of e-bus fleets as showcased in 4 dedicated demo launch events. The use cases and demonstrations have also represented a source of very valuable data to evaluate and track the developments and achievements along the project, and have ultimately paved the way for the definition of business cases for their take-up and exploitation in partner cities. All these innovations will be addressed in detail in the presentations, the roundtables, and the dedicated sessions of today. By the end of the day, you will have a clear vision on how the innovative assured solutions will allow boosting the electrification in cities towards zero, clean and sustainable transport. I hope you enjoy the exciting and stimulating event we have prepared for you. I thank you for your attention.
Thank you very much, Professor Van Mierlo, for these words. I agree with you, sustainability is our main goal, and I believe it has been as well the driving force for Assured. Our last keynote speaker, Mr. Gida, he is the Senior Director of UITPI of the Department of Knowledge and Innovation. The floor is yours.
Thank you. Good morning. It's definitely very nice to see you, if I can say, not on the screen. I think last time I made a speech like this was 26 months ago, was a kickoff of a project. So where we are after 26 months? Have we solved the climate issue? I don't think so. Have we solved the local pollution? No way. During this period, we made a test even down our house on the level of NOx, and we discovered that was much higher, I think 3-4 times the level, the maximum level which is allowed. Where we are with the congestion? Well, after the COVID, it's much worse, and we have, and we know the effect that it brings to mental and physical health. And we have something unfortunately new in the last months, which is the issue of energy. I think in the last weeks, in the last months, together with other things, we have discovered how it's important to not only to ensure successfully, let's say, ensure source of energies, and this is more strategic, this is more for government, but also to look to an efficient use of it. And this is for everyone, this is for the users. All these things are, again, pushing strongly the case for what? For urban mobility, which is clean, but also which is shared, but also for public transport, to have really a modal shift towards public transport. And we have more and more cities and authorities and operators which are really becoming more and more active. One analysis that was done to prepare this, one of the report of the Assured project, which is the Clean Bus report that is going to be published in the next days, is just the evolution. In 2017, there was a 14% of the orders were on electric buses. In 2021, is arrived at 23%, which has bring a double of a number of electric buses and clean buses that are running today in our cities. As a UITP, as the International Association of Public Transport, we have been always with the members in forefront of it. We have advocated for clean mobility. We have supported the development of policies. We have supported the members in what? In assessing, understanding the innovation, assessing the impact that this innovation has on their business. One of these being the clean bus technology and their introduction in their products and in their business. We started in 2008 with an old project that I was managed at the time that was about focusing on the auxiliaries already. But then we started having in 2011, we had the first study on e-buses. Then we had the first large project, which is called Zeus in 2014. And what we did with that project, we passed what is called the valley of death. We make the analysis, the real analysis of the real challenges that we have on the new technologies. We put all the stakeholders together. We demonstrate that the solution was valuable, was feasible, was valuable, was producing benefits. So we paved the way to the next step. And the next step was the challenge that the Assured project has successfully taken, which is the fleet upscale. One thing is, in fact, to test 1, 2, 3 vehicles. One thing is when you want to change your fleet of 200, 300 vehicles. And what you needed to look to, of course, energy efficiency again, and you need also to consider large scale like integration with high power and interoperable fast charging infrastructure. Interoperable is a key word because you are never going to change 300, 400, or 1,000 buses in one shot. You needed to have different things, different procurement, different tenders, and you needed to have different interoperable solutions. In this sense, I want just to mention one of the output of Assured, which is from the operator point of view, really an essential product that is an interoperability reference, which is available and can support the operator to verify that their new charges and vehicles are interoperable with the existing one in the fleet, but also with those of other brands. And as you can imagine, this is really key when you want to move and when you want to upscale the number of clean buses that you have on your fleet. This has been, as was mentioned by Professor Van Merlo, it has been a successful work, a successful project, which has been possible really with the collaboration of all the stakeholders, industry, operator, researchers, under the coordination, the very successful and careful coordination of VUB. And here is something I want to insist since, I would say, 2008. If you want to progress, you needed to have the producers, you needed to have the buyers, you needed to have the researchers, you needed to have the authorities, all involved. The only way to have the balance between the push from the industry and the pull from the market. Now, the project is going to a successful end, and we needed to keep the ball rolling. We have a policy framework, we have numbers and targets, then financial means that has been set by the Commission and by national governments. We have to use it now. We needed to maintain the ecosystem. And in this sense, we are working as UITP with international partners and also with the European Commission, for which we are running what is called the Clean Bus Europe platform that is supporting operators, authorities in the deployment of their clean fleet. And we have to look also to the future, to the next steps, were mentioned by Patrick Mercier before. In the last strategic research innovation agenda has been put the next steps. The next step is to extend the clean bus to all the type of bus services, looking to the BRT, looking to the on-demand services, and to consider the synergies that comes from when you put together the clean technologies together with the automation, together with the much better connectivity, with the remote maintenance, but also with the integration in the global, let's say, mobility environment and ecosystem you have. To conclude, I would like to thank the Commission for the continuous support that it is giving to the cause of clean mobility, but also to the public transport, promoting really as a backbone of mobility, which is said several times, but is still, will remain a valid concept. CINEA for the extensive management of the project, VUB for the great collaboration. We had really a great work together and a good collaboration that I really look forward to continue and to even make it bigger, and all the project partners, which has been really highly committed, considering the difficult period that we had. We never have seen a sort of a reduction of interest or commitment from the partners. That's been very, very important. Finally, I would like to thank my team from UITP, Aida, that you have seen before, Charlotte, Sarah, Rabia from the administration. As you see, we don't have a gender balance issue in UITP. They have been really the person that they have run the project together with Arno, the director of the bus unit. And let's say that if the project has been a success for UITP, it's thanks to them. I'm just speaking here like, the grandfather that is just speaking at the Christmas lunch and just introducing, let's say, the lunch to the family. So thank you very much for listening, and I pass the floor to the two ladies. Thank you.
Thank you very much. Thank you very much, Umberto, for these nice words. Well, actually, on behalf of BUB, I would like also to thank the UITP team. It has been a pleasure to work closely with you, and I have nothing but good words. Aida.
Thanks, Maitane. Also for us, it has been a real pleasure to be part of this amazing project team. Cooperation with BUB, impeccable. What else we can say? And we are very happy that we were able to manage together all the challenges we have found along the road. It has been 5 years that we have been working in this project together, and I think it's fair to say that in this time, especially considering the circumstances we have experienced in the last 2 years, the whole consortium has become stronger, more cohesion, and I would think even a bit more of a family. So this is why we would like today to thank you all again for the work done together, for the cooperation that has made possible that we arrive today with proud and joy to enjoy this final event. So I would like to invite you now to meet the Assured family.
The main goal of the Assured project is to ensure the interoperability of superfast charging solutions. For this purpose, IDIADA has led the validation activities of the charging interfaces, together with the reference partners of the industry.
Hello, I'm Iker Ibarra, Assured Project Manager at Irizar E-Mobility. The importance of standardization and interoperability in charging infrastructure can be summed up in an industry context that includes safety, cost savings, and simplicity.
Yeah, the added value from each video bus and coach for Assured is our mileage and our experience and our works which we have done over the last years in our charging test center. We have a lot of chargers from different suppliers in our charge center available, and we are testing with them together in a cooperation with in the end the goal to have a standard protocol together with the Assured project.
Interoperability is a key enabler to support bus operators to use electric vehicle and charging infrastructure at a mass scale. This has to focus not only on communication protocol, but also on hardware interface, covering the coupled vehicle plus charging infrastructure.
Mein Name ist Wolfgang Köster von Volvo Busse Deutschland. Wir sitzen gerade hier in einem Volvo Bus und wir von Volvo Busse unterstützen das Assured-Projekt zur weiteren Standardisierung in Europa. Für uns ist es sehr, sehr wichtig, dass bei Abholung und Auslieferung ein technischer Support gegeben ist.
And I'm happy to announce that everything works now. That means that it's very important that our chargers are conform the standards and that we have the interoperability so that different types of buses from different manufacturers can work with different charging providers like Heliox, ABB and Yema.
As a charging manufacturers, we contribute the Assured project with different charging technologies for buses, granting a high uptime for our chargers and giving fast answers to our Assured partners.
In Assured project, we participate designing two fast opportunity chargers of 600 kilowatts, according to interoperability criteria defined in the project. We take part within a user case, developing and testing smart charging algorithms for an operation buses fleet.
It's really a rare phenomenon, but when it happens, it really creates magic. And Assured is a project that definitely created magic. Thanks again to all the partners for all the work, your enthusiasm, your commitment, and above all, your really great team spirit to bring this project ahead. If I may ask you again for an applause for you all. But so, after this petit homage, let's continue with the agenda of the day. Yes. We have prepared, I hope you find it a very interesting program. We have 3 different modules, thematically interlinked. We will first hear about innovative energy storage systems and smart charging strategies. We will continue with the work done in Assured about standardization and interoperability with the second module, ensuring standardization and interoperability. Sorry, that's always my issue with a clicker. And the third one, exactly, and the third one is the third one is the module that will take over the results of the project. I'm just confused because I see the title is not correct, but that's the title that we will be having exactly from the lab to real operation to enable fleet upscale, meaning what we have done to prepare all vehicles, all chargers, the adaptations we run will be then tested and demonstrated in real demonstrations in cities. After that, we will continue to finish the morning session with a roundtable, which will be discussing about the results of the project, what has brought for our operators, for the cities, for the authorities, but also what are the challenges that lie ahead. For this, we count with the presence of the European Commission, we have also the presence of VUB, and of course, transport authorities and operators that will join us for this. But now, perhaps without further delay, let's start with the first module of results. So please, Maita.
Thank you, Aida. Yes, indeed, I'm glad to start with the first module. Please come to the stage. Martin Tringensu from FEB. Also, my colleague Omar, please, to the stage as well. And Felix Lefus from the Austrian Institute of Technology is joining us online. So, good morning and welcome, dear colleagues. Omar, if you want to maybe have a seat here. And yeah, now is the first presentation from FEB, from Martin. Martin, ready when you are.
Should I speak a little bit? Now it is, okay. Thank you very much. So, thank you very much for the very good introduction, for the great introduction of Assured itself. And now let's get technically. I want to present a little bit about what we did with regard to one of the key components of the buses itself, the battery system, and also want to introduce where we started from work package 2 with the requirements management. And that's the name of my presentation at all. So now I'm starting with the operational requirements and boundaries for the battery systems, coming from the holistic approach of Assured itself, and showing a little bit about the design approach itself and how we created this into the simulation platform as a model of the battery system, and a slight conclusion about what are the results of these simulations. So, as you can see here, it's one of the case sentences I found within the deliverable 2.5 provided by RENA. Understanding the requirements to the vehicle and their battery system requires knowledge of the performance targets which are requested by working every day on the route and existing constraints from the topography and charging infrastructure. I think it's one of the best sentences I heard summarizing this approach, the holistic approach to get the inputs for all the boundaries of the electrical energy storage system. And as you can see here, this is the conclusion of the work package 2, gathering all the information which are needed to combine and to lay out the specific energy storage systems for the commercial vehicle on the road. As you can see, we started with deliverable 2.1 with the specification of the city needs and stakeholder strategies. We did the specification of grid constraints, and we gathered in 2.3 the specification, the operational requirements for the vehicle, for the battery system, and the power demands for the grid itself. And 2.4, the specification for the charging infrastructure. And finally, we combined this in the KPI tree to be completely compiled and to define the KPI for measurement of the progress. And as you can see here, especially for the rechargeable energy storage system, you will have lots of boundaries, lots of inputs, lots of requirements which are definitely coming from the route or the charging station and have to be transferred into the electrical parameter or the boundaries we have to consider if we want to develop a fitting approach for different applications of electric vehicle. And here you can see requirements at a glance, what we are using. For example, we used lots of databases to comply with the holistic design or holistic inputs, like using the CIRRUS database or the use cases from Assured itself, and also other databases to get the right amount, the right amount about what we have to consider, what are the boundaries to make the development complete, like the battery operational range, the charging power, the voltage range with its constraints regarding the charging stations and the powertrains, and, for example, ambient conditions. And then we started with the general approach, how to use different chemistries for different pack types. We used mainly LTO, NMC, and leak caps for this simulations, and we made a general approach together with a verification tool from MATLAB to see what package type, what weight, what volume, and so on fits to this different applications, and how we can bring this to a scalability between different ranges or a different type of vehicle. And finally, we made the best fit strategy for a scalable pack solutions. And for the integration, finally, to the model, we built up the interfaces to the simulation platform, which has been developed in Work Package 6. And we defined the specific parameter to input this design approach into this battery system model. And we created also a cooling interface or a thermal model, which is needed for the battery system at all. And we used the SORT cycle brought from UITP, I think, to make the first simulation approaches within a scalable range of 60, 120, and 180 kilowatt hours. And here you can see this is the overall approach of how to hybridize these different chemistries, these different packs into one powertrain, as we want to see the advantage of a hybrid energy storage system which has the benefits for fast charging or peak power and long ranges. That's why we implemented this hybrid forms with two different energy storage systems within one powertrain. And finally, we made this assessment and the validation or the evaluation of the system and the simulation, as we figured out the main benefits are for sure still visible within the single source or single REST package topology, where you can see the LTO still provides a high power demand capability. The LFP cells, LFP batteries are a good mix between the energy and the peak power performance and also the costs. And NMC has the best cost solution approach, but with the restriction that mostly overnight charging is possible, that they are not that capable for high power demands of high power fast charging. And that's the way we did it. And I can conclude that the hybrid topology has also some benefits with respect to special applications where you need very high peak power performance and long ranges, but you have to take care of it that weight, costs, and additional components like DC-DC converter are necessary to comply with the powertrain and may reduce the benefit for this. So that's my introduction at all. Thank you very much. Hope you enjoyed.
Thank you very much, Martin, for this nice presentation. Actually, it's very nice and very interesting to see the assessment work that you did, having into consideration different energy storage systems, different inputs from the stakeholders, different performance targets. Amazing work. Thank you very much, Martin. And our next speaker is joining remotely. It's coming from AIT, and is Felix Lefou. I don't know if he was already with us. Yes. Hello, good morning. Thank you for joining. The floor is yours, Felix.
Thank you very much. Thank you very much for the opportunity to talk to you briefly about the results that we had in the Assured project regarding energy safety in conjunction with charging. The results I'm going to present. Minutes. For that, we applied multiple different methodology approaches. We focused on specific location scenarios with the Eindhoven bus depot, the Eindhoven end-of-line scenario, and the vehicle distribution center, of which I only want to very briefly point out the Eindhoven bus depot case, and then I would like to spend a couple of more minutes talking about the large-scale scenario in which we analyzed how fast charging of heavy-duty urban vehicles, specifically buses, affects the local distribution grids. On the next slide, next slide, please. Thank you. So the single, the local scenario that I wanted to point out or to briefly mention was the Eindhoven bus depot, where in total a charging power of 3.6 megawatts was installed, and three 1,600 kVA transformers have been used to supply those chargers. This depot supplies around 40 buses in rush moments. And as you can see on the graphic on the bottom right, due to the charging management, at no point in time a total charging power of more than 2 megawatts has been violated or overstepped. So what's important here, what's the message is that intelligent charging solutions and charging management can drastically, significantly improve or reduce the amount of connected grid power a depot like this requires. On the next slide, I want to, yes, for the large-scale scenario, we defined 3 different types of scenarios. We defined end station charging, every stage charging, and depot charging overnight. These scenarios are compared again on the next slide, where we have for opportunity charging, of course, low cost and high utilization rate. For the bus stop charging, we have higher charger cost, which is obvious since you need a charger in every bus station. And for overnight charging, we have higher battery cost, basically because the batteries of the buses need to be bigger in order to sustain a full day of operation. The next slide shows the definition in words or written text. For every station charging, we assumed 20 active charging stations with 8 to 13 seconds of charging time per stop. For every second station charging, obviously it's 10 active charging stations with a little bit prolonged charging times per stop of 13 to 23 seconds. And for the end station scenario, we had 2 active charging stations with 90 to 170 seconds of charging stations of charging time, and only 1 active charging station at night. The next slide, you can see the grid that we have used for this large-scale scenario approach. The grid is a reference grid that was developed in the DECAS project, which combines medium voltage and low voltage grids in one quite reasonable large grid model, which is it's recently typical for European urban grids. This is the reason why we use this specifically. The next slide shows the first results for every station charging. I think most important or the most interesting facts or things that can be seen here are on the right side, where you have a zoom during lunch, sometimes something around 1 o'clock until 20 minutes past 1. And what you can see are significant spikes that are caused by the charging of the buses on the grids. For the every second station charging, which is on the next slide. Next slide, please. Thank you. You can see expected a very similar picture. The spikes are significantly larger in size, but you have them less frequently, which is very obvious since you only charge at every second station. On the next slide, we have the end station charging scenario, where the size of the spike does not really increase that much compared to the every second station charging, but what's obvious is that the duration of the spike is prolonged. Again, this result is not really surprising. It's rather logical. But what I want to show you, or what's the total message of these results, starts on the next slide. If we follow one, I'm just showing the scenario for 300 kilowatt charging at every station. If those stations are connected to the low voltage grid, then you can see that there is a significant overload of the grid based on the high charging power. This is the case for every charging scenario, whether you do it every stop, every second stop, or end station charging. The picture here is very similar. We have voltage band violations, which can be seen in the bottom nodes that are turning blue, which means they have under voltage. And also we have current violations, which you can see on the red lines that are above the current loading, which is not really a nice picture. But for that reason, I have the next slide with me. For the same scenarios, if the charging stations are connected to the medium voltage grid, that is the resulting picture that you can see. There is, it's hard to say there is no issue at all, but you can see that it drastically changes the color from being troubled, as you can see now, in red and blue, and charging at the medium voltage grid. There is some voltage issues, beginning voltage issues that can be seen at the end of some low voltage feeders, which is to be expected, but in total the picture is very, very much improved simply by connecting the high power charging stations to the medium voltage grid. And on my last slide, I would like to sum up those results. So the strategies for the mitigation of grid failure due to high power charging of electric vehicle fleets. First of all, for opportunity charging, short charging durations result in spiked load behavior. Those spikes, however, did not violate the voltage bands if the EVSE or the charging station is connected to medium voltage levels. For real field implementation, an additional communication layer enabling an emergency opt-out is recommended. This would be that the grid operator has the option to say, okay, we have a real issue here, and it's more important that hospitals or other critical infrastructure gets the power right now, and dear public bus users or public transport users, heavy duty vehicle users, we are dearly sorry, but for the next 30 minutes you just have to maybe wait a minute. But we strongly recommend this as an emergency opt-out, not as a daily use opt-out. And also for opportunity charging, it's an additional measure since the battery sizes of buses suffice in most of the cases to reach the depot for most cases and scenarios. Regarding depot charging, congestion can be avoided through thorough planning, and technologies as controlled charging, load shifting, load balancing, energy management systems are highly recommended to be used in order to flatten the required grid interconnection. But this, in the most cases, is also an economic issue or an economic need of the fleet operator, because high power grid connections usually cost more money, first of all for installation and secondly for the operation, than lower power ratings regarding the grid interconnection. Finally, I can say very happily that the results of the executed simulations in the framework of Assured provide a very positive outlook regarding the grid congestions that are caused by heavy-duty vehicles which are charged with higher power in urban distribution grids. Yeah, thank you very much. I'm happy to answer your questions. You can of course write them into the chat, but I think the question session will be after Omar's presentation.
Thank you very much, Felix, of being online and available today for the Assured final event. Very nice overview on the evaluation and the modeling that has been done regarding superfast charging. Here I would like to highlight that the superfast charging does not provide a major threat to the grid safety and stability as long as the charging stations are connected to the medium voltage levels or above, as we have seen in the presentation from Felix. That's fantastic. Our next speaker, my colleague, Professor Agassi, professor and team leader of the Freie University of Brussels. Omar, ready when you are.
It's working? Yeah. Thank you, Maitana, for a very nice statement on the electrification also and following the speakers. So, go to the tools. As I heard from Martin and Felix, is very nice word about the modeling and also the hybridization. So there is a need to have tool for assisting all the result of Assured, where you can evaluate the bus performances and the fleet management in wider scope, and also to see the impact of the charging during the depot or during the opportunity charger, and then you have also the impact on the grid. So Felix has already his statement that there is no huge impact, but we need to also to see what will be happening in the vehicle itself. So my main topic today is the energy storage system hybridization already design tool that Martin already highlighted, but we are looking for this topic from the tool from simulating the line and also see the impact of the charging on it, okay? Second topic is the simulator for the eBus framework, and this also linked to the deliverables. Also deliverables, some deliverables are confidential and some are public, but don't worry that all of these results already have been published on open access journal and also conferences, so you can take a look more on the result. And then I will end by evaluation of the use case in cities. If you look forward that we talk about hybridization, and Martin mentioned, okay, that there is a need to investigate the hybridization between battery, supercapacitor, lead cabs, and also how we can manage the power electronics. And we mentioned before that we need to see the cost effective and more efficient. So which solution is fitting in our portfolio for the bus design and also the operation optimization. And then we tackle again the thermal. So the thermal is a crucial point because during the charging, the battery is getting hot. So we need to make really the thermal optimization during the charging, and then we call it preconditioning the battery thermal. So this is already done and already tested in the simulation. So if we have 6 topology already have been studied in our in design, also in simulation. First of all, that we have the battery directly connected, the battery with DC converter, the battery with supercapacitor, and the battery with really this converter and the supercapacitor directly to the DC link, and again, the battery is already connected to directly to the DC link for the converter, the traction system, and the supercapacitor via DC converter. So the idea is to really investigate what the impact of adding a new element like DC converter. DC converter can enable more flexibility on during the fast charger. And here we investigate 6 topologies, organization, architecture, and then we come to a key conclusion from this combination that we have the baseline is battery directly connected to the traction system that is really less complex, is very, we call it low cost from this perspective. And then we have also requires really an inverter, but should be wider range of operation for the inverter. So the battery is going, the voltage of the battery is going to decrease, and now we have really the performance of the motor will be really impacted by this performance. But if we go for really design tool, where we put all the requirements that we receive it from Mercury H2, as already highlighted before in morning, that we need to look at what is the minimum TCO and what will be the maximum efficiency. We need to take the trade-off. And of course, compared to the baseline. that we are. So we come to the conclusion that if we add the supercapacitor, that you could improve the efficiency or the performance by 3%, but you add an extra DC converter that could enable also improvement in the fast charging and also the traction system by around 3.5% on the traction system. So this is for investigating the possibilities of hybridization impacting the performance of the vehicle or the bus during the simulation, and also the truck. We also do this both solution for the truck and so on. We go to the simulation. So we would like to see different options. We need to see what will be the right battery size, what will be the right charging time, what will be the right power during the charging, where we can charge, where we can locate the charger. So this tool is very, very now unique tool, what I could say, because it's not coming from only Assured, it's coming building up on the Elliptic project that I think Humberto a bit forget the Elliptic project because also is really the first starting point for electrification in cities. And there we have a light version of the tool where we have single bus and single line, so the bus line itself. But here we developed a very nice tool that give you a fleet, give you also investigation during the depot, and also during the opportunity, make also design. What we call it is design, optimize, and monitoring. So it's 3 angles are already achieved. So here we have this, all of this that we need. We have the requirements operation. So we have the bus there, and we have the environmental impact, and we have also a route characteristic. We have the charging, a charging characteristic as well is fast charger or depot charging and so on. And then we have the battery condition. We never forget the battery condition because we need to do also preconditioning of the battery during the system. So all of these cases are simulated efficiently, thanks also to the partner that share all the information that we need, the data that we need from the component size and component also characterization. So we add this one inside the simulator. And then we also assess the TCO. So what will be the TCO or euro per kilometer, and also per passenger. We can also able to identify also the cost per passenger if we have. And then we have also the impact on the grid characteristic. If you go further, that you see also that we have complexity if we are going to do simulation and tool. You have model interface, so which would be the following use of the model interfaces. Luckily that we have also before that we have several EU projects that already tackling or tackled already the model interface and so on, like hi-fi element, obliques, and we account in these standard interfaces, and we collect most of this model and we can integrate together, and we able to introduce this really unique simulator tool for this. And we able to simulate 100 bus in fleet operation. Does mean that we have limitation in the tool, but the limitation on the capacity of the data that we create during the simulation. So this tool is really could be used very frequently by OEMs, by bus operator, by a designer, and so on. So we are able to simulate different routes of buses, assist also the TCO, also the energy used per kilometer destination. Also the grid analysis demand and also the energy management strategy that we introduce a new eco features. So what we come to the eco feature later that see the impact and you see how it's really complex models. So this may be for one bus. And then we also introduce a very nice user graphic interface that could be used directly with the end user. So they can already have this tool as a monitoring for the process. So it's like kind of digital twin system, but you can assist all the operation of the electric buses during the operation. So if you go further for the achievement that we are able to run a lot of scenarios. So it's simulation-wise that we could run several scenarios, several conditions, and we succeed to cover all the combination between the buses and the charger, where we see the benefit of the interoperability from point of view. And here we can see the cities that already highlighted several times before. I'm not good in this. So we also run 30 fleet optimization. So during Barcelona, Osnabrück, Gothenburg, all this already done, and also 8 optimization of charging infrastructure during the fleet. So we come to the energy management. So beside the simulator, we also develop energy management strategies that could help also to optimize the ecosystem. So what we introduce here to reduce the energy consumption via energy management, thermal management, charging management. See, we call it 3 triangles, angles from the eco. So as we see here, we introduce eco driving, eco charging, eco comfort. And this the aim to reduce the TCO and also extend the range of the vehicle and also extend the lifetime of the battery, improve the impact on the grid. So here we see the feature from the result that we have. We able to achieve really from the eco driving up to 30% reduction on the energy consumption. We call it energy saving. Thanks to that, because we optimize the drive cycle, we optimize also the recuperating energy. If you go to the eco comfort, we are able to also reduce the energy demanded, or we can improve the energy saving by around 40%. Where we have the dynamic temperature setting point, preconditioning of the cabin, preconditioning of the battery system. If you go further on the charger, of course, sometimes you see the eco charging during the operation, that you make the scheduling, the pulse techniques to charge with really opportune charger, where we can improve the process of the charging during the operation. We found that we could also achieve improvement on the charging itself during the operation. So you can see here, summarize, we have in the project of Assured, we have 12-meter electric buses and 18-meter electric buses, where we can see the eco feature, how will be impacting the energy saving. As you can see here, for 12-meter buses, we can achieve for the eco comfort 16%, from the one that I mentioned before, from the 30, and also for the eco driving, we have the huge contribution from the eco driving, but there is a very limited improvement during the charging, because the battery also is a bit smaller than the 18 buses, and also the way of more charging the 12-meter from the depot, not also from the opportunity. This is why we have limited improvements there. But for 18 buses, because the battery will be optimized with the fast charging, articulated buses, we can achieve really the 3 ecos improvements. As you can see here, that also the majority is the eco driving, but also the second one is eco comfort, and we have also improvement during the fast charging during the operation by 4% for the 18-meter bus. So this one, we come to the conclusion for the fleet. We did also the analysis for the fleet. I'm going to accelerate a bit. And then we have also a kind of really key result compared to the fleet operation, compared to the baseline. So we have also the 12-meter buses during the summer, during the winter, and we compare between the 18 and 12-meter. As you can see here, we can have also the energy uses during the system, and we can have really the fleet operation optimization. So we can achieve around TCO 2% during the operation of the fleet during the operation during inside the cities, and we can achieve also improvement in the energy usage from the grid for 8%, and also we can reduce the demanded grid during the charging by 9%. Also, all of this that already done based on the optimization we have. So we have a kind of subroutine optimization to enable the eco feature to run under the system. So here we have also, not only for buses, because we see also buses, truck, and so on, we did the same for the trucks. So the trucks, we have also trucks with interoperability between the charger and the buses, and we do also really the simulation for the heavy-duty trucks with 25 tons, and we can see here that we could achieve around 30% improvement on the energy saving during the eco driving. And of course, for eco comfort, that we have limited there because it's only one cabin. So this is really not comparable to the bus. So here we can come to the conclusion. I would like to thank you. So I'm ready for your questions.
Thank you very much, Omar, for giving us this overview on this simulation tool that was developed in Assured. Now, of course, we are going to start to get a little bit more active. We have prepared some Q&A session, but interactive. If you would like to go back to your seats, then it's not clear the correct answer. This needs to be a little bit challenging for everybody here, so we get a little bit more into the topic. And yes, we are going to start with this Slido. Everybody take your phone, please. You can do it also with your computers. If you go to the slido.com, you can directly scan the QR, or you can put the code. Yes, so we start with the first question for everybody. How can battery development optimize driving range and efficiency? Only two possible answers, 50%. Build batteries as big as you can, option A. Option B, arrange the battery needs according to the required range and charging profiles. Best fit strategy. Obviously, this is a question for warming up. So please give us your answer, your preferred answer, option A or option B to the first question. Okay, obviously, very good, correct. Everybody pass this first question. The correct answer is arrange the battery needs according to the required range and charging profiles. And meanwhile I'm talking, I'm seeing that the option B is also being selected. Well, interesting. Maybe we need to have a discussion after in the coffee break. Time to move on to the second question. Yes, this was the first one. The second one needs to be a little bit more challenging. So, what has high impact on battery aging for the rechargeable electrical energy storage system? 3 possible answers. A, high charging currents produce stress and extreme self-heating inside cells. B, low continuous current during overnight charging damages the cells extremely. Or C, ambient conditions lower than minus 30 degrees and above 60 degrees are critical for cells during charging and discharging. I'm going to say that this question is a little bit tricky because maybe there are possible options, several options that might be correct. So please don't doubt about it and select the best options for you. Here we are starting to see already the results. From here, the audience and online, 50%, 53% goes to the option A, high charging current produce stress and extreme self-heating inside the cells. The second one is getting also as important as the previous one. Ambient condition lower than minus 30 degrees and above 60 degrees are critical for cells during charging and discharging. And the last one, only 2%. Yes, correct. Everybody passes as well. These two answers are the correct ones. And then we move on to the last one. Yes, which energy management strategy has a significant impact on the energy consumption of electric buses and trucks? A, eco-comfort. B, eco-charging. C, eco-routing. Or D, eco-driving. What do you think? Eco-driving, okay. It's quite clear, Everybody is going to this option. Eco-charging is getting a little bit more popular as well. But I think we could say that the most important one would be, as you are saying, eco-driving. So, first round of questions, everybody, well done. You are approved in this round. Yes, and now I would like to tell Aida, please
I'm
join.
joining you. Now it's time. Thanks for this first round of Slido questions. Thanks for the participation. It makes it much more enjoyable for everyone and funny if you would just join us with your smartphone and help us to answer the questions. Now it's time to move on to the second module of results. We are going to talk about how to ensure standardization and interoperability of charging solutions. For this, I would like to call on stage, please, my very dear colleagues, Mernas and Jon Carles. Mernas, Jon Carles, please join us on stage. Mernas Farsam is a researcher at the VTT Technical Research Center of Finland, and Jon Carles Artigau is our colleague from A+ IDIADA. Please, Mernas, the floor is yours.
Thank you very much, Aida. Hello, everyone. I also would like to welcome you to this event and also to my presentation. I'm going to tell you about the activities that we did during Assured project on standardization and interoperability. And in today's event, we are going to hear these two words quite a lot. So I decided to start my presentation. With the definition of these two terms. When we use standardization, basically we are referring to a set of protocols or standards that consider these different aspects of charging technology for heavy-duty electric vehicles. This standardization can be, for example, regarding the mechanical properties of the charger and infrastructure, about their electrical interfaces and also their communication. And interoperability, as the previous speakers have already given some definition to you, is basically the ability of the electrical vehicle to be able to communicate and work seamlessly and without any technical problem with any infrastructure, charger system. And this would be regardless of the brand of the electric vehicle or the charger. So here in this slide, you can see basically why standardization and interoperability are important. So basically, they are the key elements for enabling the upscale for heavy-duty electric vehicles, as it provides a base for the whole market penetration, and it would basically bring the cost reduction on the infrastructure charger, and also the buyers of the technologies won't be limited or binded to only one sort of solution or brand. So here in this slide, you can see the development of European standardization on electric buses charging technologies. Basically, in 2014, the European Parliament adopted one directive on this alternative fuel infrastructure. And the reason was that to develop the standardization for this sort of alternative fuel infrastructure, since till that time there was not such standardization for that. And in 2015, the European Commission issued this mandate 533, which asked from Sensen-Elec to develop the standardization for the charging technology of electric buses. And meanwhile, while these were happening in 2013, ZEUS project had already started with the aim of uptaking the fleet of electric buses. And basically in 2016, ZEUS project, with the coordination of UITP, they arranged a committee, standardization committee, which was made of industrial partners of ZEUS project, to initiate the guideline for this standardization in collaboration with Sensen-Elec. And in 2018, this guideline was basically published as the Sensen-Elec recommendation. It included the requirements or the standardization for this fourth type of charging that you can see here, which the first one is the connector charging, and the other three are the charging with automated connective device, or ACD. And that is when Assured project started in 2017. In Assured project, there were different activities planned for interoperability testing. One of them was this Assured testing at laboratory environment at IDIADA, and then the other one was the interoperability testing at different cities of Assured. My colleague later will tell you more about these two activities, but when we were planning for these two activities, we realized that the standardization, since it was not ready yet, or if there were standardization, they were kind of a gap existing in the current standardization. So Assured project identified this need to develop a specification material that could be used for the charging solution that we are having in the Assured project, and that's when we made three working groups from our industrial partner who have been very closely following the standardization committees, and through that we could develop this document Assured 1.0, which is interoperability reference in 2019. And then based on this Assured 1.0, we developed the test protocols that would be the basis for the interoperability testing for both in the cities and also the laboratory testing at IDIADA. And after this testing were completed in 2020 and 2021, we updated this Assured 1.0 based on the result that we got from interoperability testing and also the lesson that we learned through the project. And we published the last version or the current version that we have, Assured 1.1, last year. And also another activity that basically we had on the standardization is this Assured roadmap, prenormative roadmap, which is a kind of technical roadmap to support the standardization work, but I will explain about this a bit in my further slides. So here you can see the Assured 1.1 interoperability reference. There you can see the link to this document. It is online available for you to download it if you are interested. It includes the standards and definition that have been used in Assured. And when this document initially was generated, since the standards were not complete, it was used as a reference document for our industrial partners inside Assured and even also outside Assured, so that when they wanted to develop their system, they could follow this guideline as reference. And it has the definition for mechanical interface, electrical interface, communication, and also additional like a specification that were not covered by the standards, or also the deviation from the standards that we had in the Assured. And it includes this specification for these three types of charging solution: infrastructure mounted ACD, vehicle-mounted ACD on the roof, and also ground-based ACD. Okay, here also you can see the Assured pre-normative technology roadmap. This is also available online. As you may know, basically the procedure of developing a standard is quite long. And this can, during the time that these standards are being developed, the technology can change. Therefore, the standards needs to be future-proofed. And the aim of this roadmap was to support the standardization effort by providing this general overview on the development of the charging technologies and related technology to it, so that it would consider the future needs of the end users. And also, it can be a very good reference for the end user, basically to get familiar with the charging technologies, their potentials, and also it would be kind of help for them to select what sort of solution would match their needs in future. And if you check the document as well online, you will see that you find more than the roadmap itself, but you can also see the overview of the charging technologies, the methodology that we used for it, that it includes the surveys that we carried out during the work, and also at the end you can see some use cases as a suggestion to the cities that how they can develop the use cases for their fleet, public transportation, and so on. So please, I hope you can access this and find it interesting. Thank you very much for your attention, and we are going to explain basically these activities later on in the event that we have in the parallel section this afternoon. So if you're interested, you're welcome to participate. Thank you.
Thanks a lot, Manas. It's clear we have described it from the beginning. The work on standardization and interoperability is absolutely essential to ensure that future electrification of urban fleets can be achieved in a future-proof way. We have talked about how the cooperation also among projects, starting with SEERS, the standardization committee, when there were discussions with the industry partners. At that time, we're a bit even, when you could ask, okay, are we going to reach an agreement? Are we going towards something together? This has finally taken shape in Assured, and we are very pleased that the work that we have produced in this sense can be of use and help operators, cities to understand how can they test the future chargers, the future vehicles are interoperable with existing systems, but not only this, they can also rely on a verifying tool that can give them definitely also a good decision-making tool. But now I think it's time to move on to Jon Carles to continue with how did we test and worked about the conformance testing in Assured. The floor is yours.
This is quite impressive from here, from this view. Good morning, everyone, ladies, gentlemen. My name is Jon Carles Artigau. I'm working in IDIADA, one of the project partners from the Assured project. IDIADA has been the leader of one of the multiple working groups of the project, dedicating its efforts to the Assured interoperability and conformance test of super-fast charging solutions. Okay, but first, why has Assured been so important for the heavy-duty industry? Here it is important to know first the background of the heavy-duty electric vehicles. Missing specifications and definitions of standards for electric heavy-duty vehicles prompted the urge to create a new standard. Innovation, electromobility, expertise and knowledge, and industrial thinking were necessary to cover the key points in order to achieve effective interoperability and of super-fast charging systems. One of the multiple goals of the Assured project, which IDIADA has been focused in, is to ensure the interoperability of super-fast charging solutions for reducing costs and supporting the standardization of the infrastructure elements. For this purpose, IDIADA has led the validation activities of the automated connection devices, ACDs, charging interfaces, together with the strong cooperation of the reference industry partners. As said, IDIADA has been the testing house within the Assured project, and these are the two main outcomes. First is integration of the automated connector devices solutions with IDIADA's EV and EVSE simulators to carry out the conformance and interoperability testing procedure outlined in the Assured 1.0 interoperability reference document that Mernas was talking about before. And also all the new and smart electric mobility solutions provided by all the partners have ended up being validating with encouraging and promising results. Here you can see some pictures from me and my colleague Santiago on the demonstrators in Osnabrück and Barcelona. Two important topics have been remarked here, conformance and interoperability, but what is conformance and what is interop? And why both are important? First of all, conformance. Conformance testing consists of dedicated tests for an electric vehicle or charger against a test system emulating its counterpart. In this conformance, in IDIADA, it is made the basic charging assessment for the most important regulation for the charging systems, IEC 61851 and the ISO 15118. Why is it important? It is important to have the solution ready for the interoperability testing. The IDIADA conformance testing tools to perform the validation activities have multiple features. Electrical installation capable to support super-fast chargers up to 600 kilowatts, 1 megawatt AC grid capability, of course, the IDIADA EV and EVC simulator, which features are the possibility to perform a test with real power up to 500 kilowatts, 1,000 amps, volts, sorry. Also, the ACD systems, test systems are installed, Type A, which is the inverted pantograph, Type B, which is the roof-mounted pantograph, and of course, the PLC and wireless communication interfaces are the systems which are controlled. Conformance is the first step, but it would have no sense without interoperability. So what is interoperability? In general, interoperability is the ability of vehicles and chargers, networks, and management system to interact and manage the data to ensure safety, compatibility of equipment and protocols, functionality, system reliability, and system availability. As you may know, several reference partners from the industry provided their solutions for each pantograph systems in order to perform the validation tests at IDIADA. For the invented pantograph Panto-Down, charger side ABB and Iliox, and vehicle side buses, Euliez, Irizar, VDL, and Volvo. For the roof-mounted pantograph, Panto-Up, or Type B. For the charger side, ABB and Iliox again, and the new HEMA charger. For vehicles, Irizar again, and VDL. The interoperability works continued at Transports Metropolitans from Barcelona, in Barcelona, of course, Spain, and it's Stadtwerke Osnabrück, in Germany, which both were chosen demonstration cities for the SURE project to show Panto-Up and Panto-Down solutions technologies of each partner solutions. If you're interested in to hear more details on the charging trends, technologies, and standards, more information about the Assure 1.1 interoperability reference, the prenormative technical roadmap, and more details of the interoperability testing and results, please, after the lunch break, come to and join us on the parallel session 1, standardization and interoperability of e-vehicle charging in cooperation with BTT. Thank you.
Thanks a lot, John Carles. Again, impeccable work and remarkable results. I think our audience might have found especially interesting the release of the last version of the Assured Interoperability Reference, the version 1.1. That's the work of our colleagues. I would like now to start and invite you to the next Slido round. Let's see if it goes as well as the first one. You can go back if you wish. Again, just scan the QR code and prepare. We have the first question. In your opinion, what is the best way to achieve full interoperability in the context of electric vehicle charging ecosystems? A, using same technologies in different brands of chargers and vehicles. B, testing the chargers and vehicles of different brands against interoperability, test protocol, and specifications. Again, not to trick anyone, but let's see how the results come for this question. Very good. So we have a first preferred option, testing chargers and vehicles of different brands, again, against interoperability, test protocol, and specifications. Of course, this is part of what we have been doing in the project, so it's quite easy to know. But also we see there are some votings for using the same technologies in different brands of chargers and vehicles. Very good. I think we can just move to the next one. How would you rate the importance of interoperability between chargers and different vehicle types, meaning buses, trucks, who knows, in the future perhaps what else? I have to say this was one of the questions we also were aiming to study in the project. We had some preliminary results, but how do you rate this? It's very important, it's moderately important, or it's not important at all? I think this is a quite interesting question also for our industry partners, we can have a bit of an idea if in the future we are going to see buses and trucks charging, for instance, with a pantograph. Very important. I am quite happy to see this, actually. Very good. I think with this, the positive message for the industry, just perhaps continue thinking on how to integrate pantographs also in trucks and, I don't know, perhaps other bigger sizes vehicles. Very good. Thanks everyone for the good engagement in the second round of the Slido. We have a question that was quite interesting and found interesting by the audience of the previous round. It's based on the presentation of Omar on the simulation tool. People were wondering how and when this simulation tool presented by BUB will be available for the market. We are happy to announce that this is going to be in a light version, of course. A simulation tool is something quite complex and yeah. In a light version, we will have it published on the Assured website. So I invite you to follow up the news section just to get your download of this tool. And with that, I think we can move on. Exactly. To the expected coffee break, of course. Yeah, we are already delayed. This always happens, and I am sorry for that. But I think it's time now to make a small break, just grab a coffee, have a couple of words with our colleagues, and then come back here in 10 minutes, but 10 minutes, real 10 minutes. Thanks, everyone. See you in 10 minutes.
Poor air quality and traffic congestion are pressing challenges faced by many cities today.
What?
Electrification of urban transport is considered a great solution to make our streets healthier, less noisy, and more livable. However, while more and more cities are realizing their potential, electric vehicles are often introduced in small numbers. Because charging solutions for electric vehicles are not standardized yet, the needed infrastructure to integrate them in transport networks can be very costly. Now, the Assured project aims to enable the large-scale deployment of electric fleets in cities. Assured will develop innovative solutions that will support standardization and interoperability of electric vehicles and optimize fleet operation and charging strategies. During the project, electric buses, trucks and vans will test different types of charging solutions. Assured solutions will first be tested in controlled conditions and later operated in real cities. When interoperability is achieved, operators can mix and match different brands of vehicles and chargers and integrate them in high-power charging infrastructure. By supporting the uptake of large fleets of electric vehicles, Assured will help make cities cleaner, greener, and healthier, helping Europe become a better place to live.
Standardization and interoperability of electric vehicles and chargers are key for the large-scale deployment of electric fleets in cities. When interoperability is guaranteed, operators can mix and match different brands of vehicles and chargers. This makes their integration into transport networks easier and less costly. However, the standardization of e-bus charging has not yet been fully achieved, and official standards are still not released. To support the work of standardization bodies worldwide, the EU-funded project Assured has defined a set of standards and protocols which now make it possible to test interoperability, guaranteeing flexible and cost-effective e-bus operations. Let us show you how. Assured brings together stakeholders from the entire transport and energy supply sectors across the European Union. By considering their different needs and interests, Assured creates innovative, fast-charging solutions for a more diverse and flexible electric vehicle market. During the project, electric buses, trucks, and vans test different types of charging solutions. Here, the effects of mass deployment on the grid are also considered. Let's have a look at what solutions are tested in Assured. Next to the already standardized plug manual charging solution, in Assured, 3 types of so-called automated connection devices for ultra-fast charging have been further developed and standardized. This means that buses and chargers using the same technology can work together, independent of the brand. This solution consists of a pantograph installed within the charging station. The setup requires wireless communication, and the charging starts when the pantograph has made contact to the vehicle top rails. This solution simplifies the vehicle structure. The downside is that a single pantograph failure can affect multiple vehicles. This solution places the pantograph on top of the bus, so it reduces the cost of the charging infrastructure, both along the route and at the depot. The roof-mounted pantograph is currently the most common charging solution in Europe. However, the pantograph might add some weight, height, and cost to the vehicle. Here, a current collector fitted underneath the vehicle lowers automatically and contacts the pads embedded in the ground at the bus stop to start the charging. The setup is using wireless communication and 3 contact pads. This innovative solution is further developed within Assured and has seen a successful pilot in another project. Assured is also testing wireless fast charging for vans. This technology can be useful for freight operators, as the charging can happen automatically while parking or during pickup and delivery service. By creating widely applicable and flexible charging solutions, Assured unites the interests of many different players and adapts to the diverse needs of operators and existing infrastructures of European cities. This way, Assured takes standardization to the next level, making one great leap forward towards sustainable urban mobility. Poor air quality and traffic congestion are pressing challenges faced by many cities today. Electrification of urban transport is considered a great solution to make our streets healthier, less noisy, and more livable. However, while more and more cities are realizing their potential, electric vehicles are often introduced in small numbers. Because charging solutions for electric vehicles are not standardized yet, the needed infrastructure to integrate them in transport networks can be very costly. Now, the Assured project aims to enable the large-scale deployment of electric fleets in cities. Assured will develop innovative solutions that will support standardization and interoperability of electric vehicles and optimize fleet operation and charging strategies. During the project, electric buses, trucks and vans will test different types of charging solutions. Assured solutions will first be tested in controlled conditions and later operated in real cities. When interoperability is achieved, operators can mix and match different brands of vehicles and chargers and integrate them in high-power charging infrastructure. By supporting the uptake of large fleets of electric vehicles, Assured will help make cities cleaner, greener, and healthier, helping Europe become a better place to live. Standardization and interoperability of electric vehicles and chargers are key for the large-scale deployment of electric fleets in cities. When interoperability is guaranteed, operators can mix and match different brands of vehicles and chargers. This makes their integration into transport networks easier and less costly. However, the standardization of e-bus charging has not yet been fully achieved, and official standards are still not released. To support the work of standardization bodies worldwide, the EU-funded project Assured has defined a set of standards and protocols which now make it possible to test interoperability, guaranteeing flexible and cost-effective e-bus operations. Let us show you how. Assured brings together stakeholders from the entire transport and energy supply sectors across the European Union. By considering their different needs and interests, Assured creates innovative, fast-charging solutions for a more diverse and flexible electric vehicle market. During the project, electric buses, trucks, and vans test different types of charging solutions. Here, the effects of mass deployment on the grid are also considered. Let's have a look at what solutions are tested in Assured. Next to the already standardized plug manual charging solution, in Assured, 3 types of so-called automated connection devices for ultra-fast charging have been further developed and standardized. This means that buses and chargers using the same technology can work together, independent of the brand. This solution consists of a pantograph installed within the charging station. The setup requires wireless communication, and the charging starts when the pantograph has made contact to the vehicle top rails. This solution simplifies the vehicle structure. The downside is that a single pantograph failure can affect multiple vehicles. This solution places the pantograph on top of the bus, so it reduces the cost of the charging infrastructure, both along the route and at the depot. The roof-mounted pantograph is currently the most common charging solution in Europe. However, the pantograph might add some weight, height, and cost to the vehicle. Here, a current collector fitted underneath the vehicle lowers automatically and contacts the pads embedded in the ground at the bus stop to start the charging. The setup is using wireless communication and 3 contact pads. This innovative solution is further developed within Assured and has seen a successful pilot in another project. Assured is also testing wireless fast charging for vans. This technology can be useful for freight operators, as the charging can happen automatically while parking or during pickup and delivery service. By creating widely applicable and flexible charging solutions, Assured unites the interests of many different players and adapts to the diverse needs of operators and existing infrastructures of European cities. This way, Assured takes standardization to the next level, making one great leap forward towards sustainable urban mobility. Poor air quality and traffic congestion are pressing challenges faced by many cities today. Electrification of urban transport is considered a great solution to make our streets healthier, less noisy, and more livable. However, while more and more cities are realizing their potential, electric vehicles are often introduced in small numbers. Because charging solutions for electric vehicles are not standardized yet, the needed infrastructure to integrate them in transport networks can be very costly. Now, the Assured project aims to enable the large-scale deployment of electric fleets in cities. Assured will develop innovative solutions that will support standardization and interoperability of electric vehicles and optimize fleet operation and charging strategies. During the project, electric buses, trucks and vans will test different types of charging solutions. Assured solutions will first be tested in controlled conditions and later operated in real cities. When interoperability is achieved, operators can mix and match different brands of vehicles and chargers and integrate them in high-power charging infrastructure. By supporting the uptake of large fleets of electric vehicles, Assured will help make cities cleaner, greener and healthier, helping Europe become a better place to live. Standardization and interoperability of electric vehicles and chargers are key for the large-scale deployment of electric fleets in cities. When interoperability is guaranteed, operators can mix and match different brands of vehicles and chargers. This makes their integration into transport networks easier and less costly. However, the standardization of e-bus charging has not yet been fully achieved, and official standards are still not released. To support the work of standardization bodies worldwide, the EU-funded project Assured has defined a set of standards and protocols which now make it possible to test interoperability, guaranteeing flexible and cost-effective e-bus operations. Let us show you how. Assured brings together stakeholders from the entire transport and energy supply sectors across the European Union. By considering their different needs and interests, Assured creates innovative, fast-charging solutions for a more diverse and flexible electric vehicle market. During the project, electric buses, trucks and vans test different types of charging solutions. Here, the effects of mass deployment on the grid are also considered. Let's have a look at what solutions are tested in Assured. Next to the already standardized plug manual charging solution, in Assured, 3 types of so-called automated connection devices for ultra-fast charging have been further developed and standardized. This means that buses and chargers using the same technology can work together, independent of the brand. This solution consists of a pantograph installed within the charging station. The setup requires wireless communication, and the charging starts when the pantograph has made contact to the vehicle top rails. This solution simplifies the vehicle structure. The downside is that a single pantograph failure can affect multiple vehicles. This solution places the pantograph on top of the bus, so it reduces the cost of the charging infrastructure, both along the route and at the depot. The roof-mounted pantograph is currently the most common charging solution in Europe. However, the pantograph might add some weight, height and cost to the vehicle. Here, a current collector fitted underneath the vehicle lowers automatically and contacts the pads embedded in the ground at the bus stop to start the charging. The setup is using wireless communication and 3 contact pads. This innovative solution is further developed within Assured and has seen a successful pilot in another project. Assured is also testing wireless fast charging for vans. This technology can be useful for freight operators, as the charging can happen automatically while parking or during pickup and delivery service. By creating widely applicable and flexible charging solutions, Assured unites the interests of many different players and adapts to the diverse needs of operators and existing infrastructures of European cities. This way, Assured takes standardization to the next level, making one great leap forward towards sustainable urban mobility. Poor air quality and traffic congestion are pressing challenges faced by many cities today. Electrification of urban transport is considered a great solution to make our streets healthier, less noisy, and more livable. However, while more and more cities are realizing their potential, electric vehicles are often introduced in small numbers. Because charging solutions for electric vehicles are not standardized yet, the needed infrastructure to integrate them in transport networks can be very costly. Now, the Assured project aims to enable the large-scale deployment of electric fleets in cities. Assured will develop innovative solutions that will support standardization and interoperability of electric vehicles and optimize fleet operation and charging strategies. During the project, electric buses, trucks and vans will test different types of charging solutions. Assured solutions will first be tested in controlled conditions and later operated in real cities. When interoperability is achieved, operators can mix and match different brands of vehicles and chargers and integrate them in high-power charging infrastructure. By supporting the uptake of large fleets of electric vehicles, Assured will help make cities cleaner, greener and healthier, helping Europe become a better place to live. Standardization and interoperability of electric vehicles and chargers are key for the large-scale deployment of electric fleets in cities. When interoperability is guaranteed, operators can mix and match different brands of vehicles and chargers. This makes their integration into transport networks easier and less costly. However, the standardization of e-bus charging has not yet been fully achieved, and official standards are still not released. To support the work of standardization bodies worldwide, the EU-funded project Assured has defined a set of standards and protocols which now make it possible to test interoperability, guaranteeing flexible and cost-effective e-bus operations. Let us show you how. Assured brings together stakeholders from the entire transport and energy supply sectors across the European Union. By considering their different needs and interests, Assured creates innovative, fast-charging solutions for a more diverse and flexible electric vehicle market. During the project, electric buses, trucks and vans test different types of charging solutions. Here, the effects of mass deployment on the grid are also considered. Let's have a look at what solutions are tested in Assured. Next to the already standardized plug manual charging solution, in Assured, 3 types of so-called automated connection devices for ultra-fast charging have been further developed and standardized. This means that buses and chargers using the same technology can work together, independent of the brand. This solution consists of a pantograph installed within the charging station. The setup requires wireless communication, and the charging starts when the pantograph has made contact to the vehicle top rails. This solution simplifies the vehicle structure. The downside is that a single pantograph failure can affect multiple vehicles. This solution places the pantograph on top of the bus, so it reduces the cost of the charging infrastructure, both along the route and at the depot. The roof-mounted pantograph is currently the most common charging solution in Europe. However, the pantograph might add some weight, height and cost to the vehicle. Here, a current collector fitted underneath the vehicle lowers automatically and contacts the pads embedded in the ground at the bus stop to start the charging. The setup is using wireless communication and 3 contact pads. This innovative solution is further developed within Assured and has seen a successful pilot in another project. Assured is also testing wireless fast charging for vans. This technology can be useful for freight operators, as the charging can happen automatically while parking or during pickup and delivery service. By creating widely applicable and flexible charging solutions, Assured unites the interests of many different players and adapts to the diverse needs of operators and existing infrastructures of European cities. This way, Assured takes standardization to the next level, making one great leap forward towards sustainable urban mobility. Poor air quality and traffic congestion are pressing challenges faced by many cities today. Electrification of urban transport is considered a great solution to make our streets healthier, less noisy, and more livable. However, while more and more cities are realizing their potential, electric vehicles are often introduced in small numbers. Because charging solutions for electric vehicles are not standardized yet, the needed infrastructure to integrate them in transport networks can be very costly. Now, the Assured project aims to enable the large-scale deployment of electric fleets in cities. Assured will develop innovative solutions that will support standardization and interoperability of electric vehicles and optimize fleet operation and charging strategies. During the project, electric buses, trucks and vans will test different types of charging solutions. Assured solutions will first be tested in controlled conditions and later operated in real cities. When interoperability is achieved, operators can mix and match different brands of vehicles and chargers and integrate them in high-power charging infrastructure. By supporting the uptake of large fleets of electric vehicles, Assured will help make cities cleaner, greener and healthier, helping Europe become a better place to live. Standardization and interoperability of electric vehicles and chargers are key for the large-scale deployment of electric fleets in cities. When interoperability is guaranteed, operators can mix and match different brands of vehicles and chargers. This makes their integration into transport networks easier and less costly. However, the standardization of e-bus charging has not yet been fully achieved, and official standards are still not released. To support the work of standardization bodies worldwide, the EU-funded project Assured has defined a set of standards and protocols which now make it possible to test interoperability, guaranteeing flexible and cost-effective e-bus operations. Let us show you how. Assured brings together stakeholders from the entire transport and energy supply sectors across the European Union. By considering their different needs and interests, Assured creates innovative, fast-charging solutions for a more diverse and flexible electric vehicle market. During the project, electric buses, trucks and vans test different types of charging solutions. Here, the effects of mass deployment on the grid are also considered. Let's have a look at what solutions are tested in Assured. Next to the already standardized plug manual charging solution, in Assured, 3 types of so-called automated connection devices for ultra-fast charging have been further developed and standardized. This means that buses and chargers using the same technology can work together, independent of the brand. This solution consists of a pantograph installed within the charging station. The setup requires wireless communication, and the charging starts when the pantograph has made contact to the vehicle top rails. This solution simplifies the vehicle structure. The downside is that a single pantograph failure can affect multiple vehicles. This solution places the pantograph on top of the bus, so it reduces the cost of the charging infrastructure, both along the route and at the depot. The roof-mounted pantograph is currently the most common charging solution in Europe. However, the pantograph might add some weight, height and cost to the vehicle. Here, a current collector fitted underneath the vehicle lowers automatically and contacts the pads embedded in the ground at the bus stop to start the charging. The setup is using wireless communication and 3 contact pads. This innovative solution is further developed within Assured and has seen a successful pilot in another project. Assured is also testing wireless fast charging for vans. This technology can be useful for freight operators, as the charging can happen automatically while parking or during pickup and delivery service. By creating widely applicable and flexible charging solutions, Assured unites the interests of many different players and adapts to the...
now.
Here we are. Thank you.
Welcome from the coffee break. I hope you all have a little bit more energy. We're continuing now with the next round of results, the third one with question and answers again. So please, everybody. Okay. So this is the last block of the results, as I was saying, and we are going to have several speakers as well. Aida, first of all, from UITP, welcome. Stamatis Mangiaris from ICCS as well. Roel van Groot from TNO, and Fabrizio Camisetti from RINA. So we will now hear about, or be a little bit more closer to the users, to cities, to the demos, to the operators, as well as to the research questions and the business models that have been done in the project of Assured. And we will start with you, Aida, whenever you want.
Thanks a lot. So I hope everyone has already tanked a bit of energy, or yeah, we should say recharge a bit of energy, because the last part of the morning is not at all losing pace with the first part of the morning. So I would like just very briefly, because we know we are delayed, and it's good always to get a bit of time back. So I will just share with you some of the highlights of the Assured demonstrations. Of course, whatever we have done in this project makes definitely no sense if there is no one end user who is able to extract the value from it, deploy it, and use it. How many innovations you know, or called innovations, that at the end they just stand at the lab or just in a drawer? So with this leading thought, what we have done in Assured is what my colleagues already presented to you before. We have tested under control conditions, lab conditions, all the changes we had done in the vehicles and the chargers, because logically we needed to adapt these applications to be able to comply with the requirements, the needs of the citizen operators that we defined at the beginning of the project. It's true that it was back in 2018, I think, so might be requirements today have changed a bit, but this is the work we have done, right? So once we had these vehicles and these applications adapted, what we did is to verify under control conditions as a pretest before the real operation in the demos. Short reminder, in Assured, we have 3 different pillars. You know, it's not just about buses. Of course, the buses have a very, let's say, heavy weight in the project, not just because of the real weight, but also because of the importance of the topic of public transport. So, but I would like to remind you about the different pillars. We had the first pillar, again, electric buses, with these partners you see on the screen. We had an Helios bus, Iveco bus, a Volvo bus, Irizar, and VDL. And this, what you see here, are the, let's say, lab test sites. We also have Pillar 2 and Pillar 3 on electric trucks by MAN and our colleagues from Volvo, and electric vans by our colleagues from Tofaş manufacturer. So what we did in the demonstrations in the cities is basically take these applications that were adapted to fulfill the requirements of the end users and test them in real operation. For that, we had 1, 2, 3, 4, 5 demo sites. Barcelona and Osnabrück were testing the interoperability between buses and chargers, of course, within the same technology. In Gothenburg, we demonstrated several solutions for high-power fast charging. And Eindhoven and Jaworzno were focusing a bit more what happens when you need to upscale a fleet. I will tell you a bit more in the next slides. Just wanted to share with you some of the visuals. Of course, this has been amazingly challenging during this pandemic. It was quite an issue to put together demonstrations that mean bring buses to a demo site, make them working, running in the existing fleet of the operator, that the chargers are working, that the buses are working, and that nothing goes, let's say, a bit aside of what we have planned. This was an amazing work. Of course, it implied a lot of coordination, a lot of cooperation, a lot of flexibility, I want to say, from each of you. So this was able because of your commitment and your engagement again. So you can see here, just have a look to the pictures of the demonstration. We tested roof-mounted pantograph in Barcelona, okay? We had two buses, two different brands. We had the VDL buses and we had the Irizar buses. And we had the chargers of Yema, ABB, and Heliox. I will tell you in another occasion about what it means to install, of course, a charger in public space. I guess you all know that. But here you have the second demonstration in Osnabrück. Here we were testing infrastructure-mounted pantograph. And you can see here in the slide, we had snow, we had delays because of the snow, we had the civil works. I mean, Herman was in the video, no? And in the video, Meet the Assure family, already explaining to you, at the end, everything worked, and we were able to test and to successfully demonstrate the interoperability of the buses. Here we had 4 different buses. We had VDL, we had Volvo, we had Heliobus, and also Irizar. You can see in the first picture the arrival of the nice Irizar bus. That was also the stage of the Osnabrück demo launch. If you haven't seen the recorded, of course, I don't talk to my partners, I talk to the people online. Just go to the website because all recordings are available and they are really, really very worth it. The interesting point I don't want to miss from this demonstration was that, of course, to, let's say, link the gap, the time gap for the approval of the permits to connect to the grid, we installed in Osnabrück, as you can see in the last picture at the top right corner, a power box, because we wanted to make sure that we can do the testing before the operation of the buses. Buses performed fantastically. We will hear in the round table at the end of the morning how the operators have also experienced this. And what else to say? I mean, both demonstrations have provided a lot of results and data. Omar was also presenting before for the simulation tool, etc., how these data were also implemented in the project. In Gothenburg, that was the first demonstration we launched back in October 2020. What we demonstrated there is interoperability between different applications, bus, truck, van. Here, we were trying also to showcase what is flexible, interoperable charging with, and the goal of the demo itself was definitely to show you which are the solutions that at that time Volvo was implementing. So we had indoor bus charging. You can see here in the picture, that's a very nice result also from the EVSF2 project. You might have heard about that, where there was the design of an indoor bus station. When we talk about electric vehicles, buses in this case, of course, the question comes also, what happens if I need to approach, let's say, more sensitive zones? This technology gives you the chance to have buses closer to people. In this case, in the picture, this bus is just right next to the cafeteria in the campus of the university in Lindholmen in Gothenburg. So we also saw infrastructure-mounted pantograph up to 450 kVs, also high-power CCS charging for trucks and cars. You have there the pictures of the different vehicles charging, and also it was a premiere of the launch of the roof-mounted pantograph bus. Moving from Gothenburg to Eindhoven, what to say? This is exactly the question that we are trying to address now. We started a project trying to answer the question, okay, how do we go from small-scale deployments to a bigger-scale deployments? Well, these guys have done it. These guys have designed a future-proof way of upscaling a fleet from 43 buses to 100 buses. There's a lot of results you are going to get. It's really, really important because this is exactly what all operators and cities are looking at today. So what is actually the purpose of this demonstration? It's not the same, and I am paraphrasing my VDL colleagues here, it's not the same to deploy 5 buses, even 40 buses, than to deploy 100 buses. It's not copy-paste, and I think this is exactly what my colleague said in the demo launch. As it is not copy-paste, we need to be careful when we define the system to proceed with this upscale. First, to ensure that power supply is there, grid connection is there. We don't need to oversize or over-dimension the connection grid. I think it's a very relevant topic we will be also touching perhaps upon on the round table. It's a key point, and at the end, how does it work? Well, with a smart charging and being also smart in the design. And again, paraphrasing my colleagues, we go from e-mobility to I-mobility, to intelligent mobility. Finally, the last demonstration in Jaworzno in Poland. Here, we were trying to understand which are the charging strategies that could work also to reduce the energy consumption, of course, also with not just the purpose of fleet electrification. We had 23 buses there. We do have 23 buses there, but with the view in the future how to proceed with the fleet renewal exercise, how to go to zero-emission fleets, and how to reduce, of course, as an overall goal, not the CO2 emissions. There is, I think, it's like it's a combination of overnight charging at the depot with CCS2 and opportunity chargers on street. A lot of results. Our colleagues from VUB also have followed very closely this demonstration, also to be released very soon at the end of the project. It was quicker than I thought, actually. I hope you have got a good overview. And with this, I will then just hand over to Maitane. Thank you.
Thank you, Aida, for this nice overview of the demos. Now we have a following speaker. Actually, we were discussing a lot on electric buses and electric trucks, but what about Evans? The floor is yours, Stamatis.
Okay, hello everybody. My name is Stamatis Maganaris, representing ICCS Work Package 7 leader. I offer the most grateful welcome to all the audience, the physical one and the virtual one. It is a great honor for me joining Assured project from 2020, replacing my colleague Christina. So, in Assured we didn't work only on buses and trucks, but on lighter vehicles like vans. And we worked on the inductive charging or wireless charging. But let's start our presentation with a video, please.
So, good morning and welcome to the Power Electronic Innovation Center. This is an electronic lab, just a nice name. There's a lot of people working here in the power electronics field, drives, etc. And here is the place in which we test our Assured water power transfer system, please. And I'll let you know and let you see where it is, so we can define the table on which the computer is interfaced with the system, the scopes, the power supply for only the losses, because this is a closed-loop test in which we recirculate the power and we can supply only losses. Well, here are all of the pieces we are developed and created. As the project will require, there's two prototypes, and you can see one of the two is in the middle of a sort of reconstruction, while the final one, the only one tuned, is in there. The distance is not the correct one, but actually it's a bit higher just to let you see it, the shape of what is on the transmission side, what is on the receiver side. The two systems more or less are identical, and you have the three-phase coil connected on the bottom, and the same on the top. We remove the protections. This is the one that stays on the bus. Okay. Well, the system if my colleague helped me, is based on 3 coils shaped this way in order they can be overlapped one over the other in order to reduce, minimize, or zeroing possibly the mutual coupling in transmission and the receiver side. The final effect is that this system is totally decoupled and the power transmission remain better and easier applied. What else to say? Everything is in the box. So coils, power capacitors, the rectifier diodes. So on the system you simply have to connect plus and minus, nothing else. And the size is not small after all, but we are talking about 100,000 kilowatt power peak. No cooling system is foreseen for this system, and also the shielding will be simply based on aluminum. This is the power electronic system, water cooled, that is being removed from the box, the industrial box we adopt for the final testing, just to make the circulating test. It's based on a unique control developed by us, designed by us, and 2 silicon carbide 3-phase systems with 3 amps continuous current available till 100 kilohertz, 150 kilohertz of switching frequency. Everything is cooled on behind, and that's it. I hope you will appreciate the work that Jacopo has done, because this is his PhD student thesis financed over the Assured project. So thanks a lot and have a nice day.
So I think you found interesting this video. It was my colleague Paolo from Polytechnic of Torino, and he presented to us the wireless power unit. Speaking about the inductive charging or the wireless charging, we can say that is more convenient and less time consuming than the conventional charging. And I will give you some examples. For instance, if you have bad weather conditions or snowing, the driver does not have, if we speak about lighter vans, lighter vehicles, to get out of his car. Also, inductive charging or wireless charging does not include any moving parts that can break or sparkle. And I would say that wireless charging, either we speak about service or fleet goods delivery, or let's say private cars, I would say that is the most suitable, or the connection to the automated vehicles, to the autonomous vehicles. Of course, we can say that ACD also is close to the concept of automated vehicles, because in wireless charging, the vehicle is parked and charged in much less time. So these are the advantages. Let's see what we have done in use case 9. We cooperated with TOFAS and Polytechnic of Torino, and us as ICCS, we are the coordinators. I'll go a little quickly through the first slides, since they were more or less presented by the video of Paolo. Here you see also the electric and electronical activities in more details. Of course, such a task involved the virtual integration activities and the virtual feasibility for wire power transfer, the system presented by Paolo in the video, thermal system, geometric integration, and prototype vehicle integration. But here we have the vehicle. The vehicle from our partners in Turkey, TOFAS, and here you can see the HV components and the photographs. Of course, the relevant electrical system and software activities concerning LV, energy management, UPT system integration, software functions, optimization, electric and electronic functional integration. And of course, the demonstration tests involve the system initialization, the basic functionality, wireless power transfer, mechanical and electrical integration, error handling, static charging system functional and performance, very critical for the test. And here you have some technical aspects. You see that the vehicle platform was Fiat Doblo, Cargo Max, some technical characteristics, acceleration, autonomy, nominal voltage, and from the TOFA's premises, some photographs of the vehicle that was used. Okay, speaking about tests and proving our results, the power tools and measurements bench is very important. Here are its elements, the power bench with its DC power, the DC measurement bench, and of course AC measurement bench. A very important, let's say, innovation was the silicon carbide inverter that was presented in the video before, that was tested with zero current and zero voltage. Here we see also the EMC measurements with the exposure level testers and the battery emulator and the relevant photograph. And here are the results of which I'm really proud. Why we are proud as Ashut for these results? Because I described before the advantages of wireless charging, but till now there are still some disadvantages that has to do with the lower efficiency in relation to the cable, the conventional charging. This is due to the fact that a part of energy is lost to heat. But here we have these two numbers, I repeat, that we are proud of. So we, our colleagues in Torino and TOFAS, achieved to transfer 100. The aim was for 100 kilowatts, but you see that we achieved 100.04 in the bottom. If you compare this to what was done till then, it was the baseline was 22. So compare 22 before Ashut to 100 after Ashut. Concerning efficiency, we had, or even we have, as less as 60% till now, and in Ashut, we achieved over 90. You see in the bottom, 94. I think that also there are two impressive results. We tested two scenarios, the hot one and the ideal one. Hot scenario meaning 35 degrees. Even in the hot scenario, as you can see, the vehicle was able to charge for up to 10 minutes. In the ideal scenario, the colder, let's say, or the cooler one, we reached up to 12.5 minutes. And what is also very important about the energy consumption and the environment, the Ashut electric vehicle, as was developed by Ashut, TOFAS, and Polito, has an energy consumption 66.6% lower than the diesel conventional vehicle. That's all for me. Thank you for your attention.
Thank you very much, Stamatis. It's great to see that this technology is progressing more and more with also these actions of Ashut. Thank you. And then we move on to our next speaker, Roel de Groot from TNO. And of course, at the beginning of a project, we always need to think about the research questions that are going to be tackled, right? So I think this is going to be one of the points that we are going to discuss now with Roel. Whenever you want, Roel, the floor is yours.
Yes, good afternoon, everybody, also online. I will be presenting the evaluation work package in Assured. And evaluation is about looking back and putting numbers to KPIs, for example. But we had a slightly different approach, and we thought at the beginning of the project, what are we trying to do? We try to answer certain questions and to assess the innovations that are part of the project. So we had quite an extensive inventory about research questions. And just to give you an example of what we mean with a research question is in what way do we now understand the impact of fast charging on battery lifetime? And another one, what is the impact of fast charging on the grid, on the quality, the stability and the reliability? So how did we arrive at those research questions? So we started way back in the call text, which the Commission basically asked us to achieve certain requirements in terms of energy efficiency, for example, and interoperability. But also in the description of work in the proposal, we made implicit and explicit promises of what we should or we're trying to achieve. So this was done in the beginning of the project. The next step we took in the evaluation process was to link the research questions to certain KPIs. This is all reported. I understand them. Okay. This is all reported in a public deliverable. So if you're interested in these research questions and the associated KPIs, please take a look at it. And later in the project, when the use cases and the demonstrations matured, the KPIs were also linked to those use cases and demonstrations. Again, this is the linking is reported in a public deliverable. And the second step is that we, of course, need evidence to answer those research questions. And on top of just doing measurements, we had quite a broad approach in the project. And we used, for example, simulations for the research questions that are associated with fleets. To implement a complete fleet in a project, to, for example, assess the impact on the grid, it's too much work, it's too costly. So the simulation models, for example, from Work Package 6, are quite valuable in answering some of those associated research questions, and the ones associated to cost could be done with work done by the colleagues from RENA in Work Package 10, for example, on the TCO modeling. But even more important, getting insights and best practices from the people who actually work with the technology are extremely valuable. And we collect those with interviews and learn how is the technology performing in practice and what could be done to even further improve it. And that's the privilege of an evaluation work package. We can also look at the work done by other partners and in other work packages. This work was all organized in 3 pillars. So we distinguished between vehicles, the chargers and the grid. And in each of those pillars, dedicated measurements were done. For example, on the frequency related to the grid, but also charger efficiency, and in the vehicles, operational data was collected during the demonstrations. This work is also available in a public report which is on the data collection. So again, if you're interested, please take a look at this report. Then the actual evaluation task itself, so that's finding the answers to the research questions, was done in a way which you may not find in other reports, but we structure it according to the stakeholder perspective. That's the public transport operator, or the OEM, or the grid operator. And per stakeholder, we listed the relevant research questions and answered those questions, come up with clear findings, conclusions and recommendations, and also put that into perspective of the project and, for example, the use cases and demonstrations. There's quite a lot of information in that report. It will be published within, let's say, a couple of weeks. So we are now really finalizing all the details. But just to highlight what you can expect, and for example, on the interoperability. So you earlier today heard about the test protocols and the infrastructure. This was all accomplished to what was promised in the proposal and the call text. And the facilities were successfully used to test chargers and vehicles on interoperability. During those tests already issues were encountered, and most of them could be solved by making modifications to software, for example. And as a next step, the tested vehicles were put into the demonstrations and were again successfully tested. So this is a very welcome result of the project. On the standardization, we could conclude that it was also a success. So the interoperability reference was published, and we learned that it is even already used today in tenders for buses and chargers. So one of the drivers of the project was to prevent vendor lock-in between vehicles and chargers. This is really being addressed by this deliverable and the fact that it's being used in tenders. Another highlight of the conclusions of the research questions is on energy efficiency. Typically, we could conclude that faster charging is not that favorable in terms of energy efficiency because the battery is heating up, internal resistances are increasing, and this energy has to be cooled also away, costing more energy. But if you look at the energy consumption of vehicles, we found quite a large range of what you can expect in terms of kilowatt hours per kilometer. And it ranges from just over 1 kilowatt hour per kilometer to almost double that value. But it really depends on the technology that you use, the type of operation, and the weather condition. And as we could see before in Omar's presentation, there's things that you can do to reduce your energy consumption. For example, on the eco-driving, that's a measure that can be taken relatively easy by training your drivers. Another measure, which also had a significant potential, was on eco-comfort. Last aspect is related to the fleet upscaling in Eindhoven, because this is very interesting from an evaluation perspective, because this is a fleet that went into operation in 2016 when the project has been set up at the same time. So in this period between 2016 and now, a lot of information and best practices have been gathered with electric buses on a significant scale. So over more than 10 million kilometers have been driven with the fleet, just to give you an impression, and the number is counting up even as we meet here today. What could be concluded is that the constraints and boundary conditions that were valid in 2016 are also valid still today. But what has improved in the meantime is the state of the technology. It has advanced. Batteries have become cheaper, bigger, better. And with the same specification, it means that your electric bus today will have a wider range in which it can operate. And at the same time, this also gives room for optimization. So imagine that you have real-life data from your fleet, depending on the actual operation, the weather conditions of the day, the ridership of the day. You can make decisions during your operation to optimize for TCO and to adapt your charging scheme if you, for example, deploy energy storage in battery systems. As highlighted before, what we now observe from Eindhoven is that the electric bus fleets can be put in operation, So e-mobility is achieved, you could say, and next step is to go to I-mobility, so to make use of all the information you collect from the operation and make decisions to further optimize to reduce TCO after all. This report, it's also finished 99%, so it will be released within the coming days. And again, there's quite a lot of valuable information in it, so I really recommend you to read that. Just to also conclude on a more personal note, the evaluation is we are looking retrospectively at the work from others and assess their performance. And it's people's work, and I would like to especially thank Sarah Fotza from RINA. She has really done the groundwork on the KPIs and the research questions. And Manuel and Johannes, Manuel's here today, they did really hard work on collecting all the data in difficult circumstances during Corona. So compliments for them, and Robert and Nikos. Robert's here today, Nikos couldn't make it due to private reasons, who pulled, let's say, everything together to arrive at conclusions. Jan and Peter, and the name of Tim is not mentioned, but the role of VDL was especially important because they shared all kinds of best practices, how electromobility can be put in our streets. And now, wondering if the other slides also made it to the final presentation. So to conclude, when I was doing this, and evaluation is also a moment of reflection perhaps, I could imagine that it was my first occasion that I got into contact with European proposals. That in 2016 we first met with Noshin at the CNH Museum. And now here we are at the end of the project also in a museum, so you could say that the circle is closed. And another thing that I remembered, and a colleague who accompanied me in 2016 in Turin reminded me that in 2016 I broke my foot, and now I got surgery on my arm, so from that perspective the circle is again closed. So thanks for your attention. Yeah.
Thank you very much, Raul. Indeed, the circle is closed, and I would say as well that with great success. So now we go to the last presentation of the block, and I would say the last one of the plenary. It's a pleasure to welcome Fabrizio Camisetti, and it's the topic, of course, on business modeling and deployment strategies. Fabrizio, the floor is yours.
Thank you. First of all, it's a pleasure to be here to see you again in person and not via Teams and all the other tools we have used for about 2 years and more. So this is the first, the workflow of our work package. And as Raul said, we was in the line and at the end of the process, and we collected several data, several info, several measurements, several results coming from the other work package and the other tasks made by the other colleague. And the topics were very wide, so we have to draft the business cases. We have to make the evaluation from economic, social, environmental point of view. We made the design of some business models. We draft also the deployment strategies for cities. And finally, we prepare the exploitation plans. So about the business cases, here we have to scratch, and we have built the business cases, taking all the improvement that we have seen in the use cases and in the demo cities, and trying to highlight the key results coming from the evaluations and all the work, as I said, in our work package. The business case, I would like to underline that are set considering the main elements that are positively tested in real operation by the demo leader, and I take the opportunity to thank all the demo leader and the use case leader to having shared data, confidential data, info, and numbers, critical numbers. And as I said, we showed the economic and financial aspects and social and environmental aspects. What we have considered, we have included as much as possible all the parameters we have collected. So all the asset compositions that we see in the demos and in the use cases. We take the operational needs and requirements that the other partners give to us. We take distances, consumptions, distance traveled, battery capacity. We have considered all type of data, and we used this to make some evaluation. The two scratch we have seen here are based on the first on Panto up solution and the second Panto down solution, and using the fast charging solution along the line. Coming to the economic impact, as I said, we made financial and economic analysis for each business cases, and the objective was to have the performances and show the sustainability of the solution we draft. So the results have been produced in corporate finance way, and we included the cash flow, the net present value, the internal rate of return, and these results were all collected and analyzed. And you see the first picture is the cash flow, the cumulative cash flow, and containing also the opportunity for financing that abbreviate the return of the investment. All the performance that were evaluated was also checked with the sensitivity analysis, and the objective was to see which can be the parameters affecting the results with heavy weight. And this activity was also important to share this kind of info with the colleague of TNO for the research questions and the impact of the solution tested. The second picture you can see in the slide is the results, the comparison of results of TCO using fast charging, using plug-in, and the comparison with diesel vehicles. And was made to see if the solutions that we measure and tested and view was sustainable. And the replies was yes, this was sustainable. The last picture is has the objective to show if the composition of the fleet was changed, what happened to the TCO, and so the changing the composition of reducing the number of articulated buses or 12-meter buses, so maintaining the same operational requirement and maintaining the same infrastructure at the depot and along the line, how these numbers can change, and if these produce an important results from the sustainable point of view. And there was also in this case, yes. The different color, I don't see if are readable, but highlight the cost composition, the different type of cost composition. We have also made in the same work package the environmental and social impact. So we have used the life cycle assessment methodology from the environmental impact and the disability adjusted life year to calculate the social impact. And the result was that the technology performed generally better than diesel, and that the charging infrastructure contribution to emission could be negligible considering the whole life of the vehicles, so assuming 15 years. The social impact are different also here, and we will see also in the other slides, according and about the specific line that are under analysis. And have to be also considered that for the social impact, the electricity play a role in the evaluation. So if the electricity is produced in the place of measurement or in the other places. We have also drafted the business models, and this was done before this part was drafted an activity that contained the value system, a market overview, the competitor analysis, and the potential business opportunities. Some of this info come from the other work package, some other were taken through interview and surveys and questionnaire stressing some partners to obtain this indication, mainly the potential opportunities, the criticalities, and the growing rate. To design the business model, we used the Canvas methodologies, and also to define and evaluate the various business models. Inside each, we have described the key characteristics, the links between the different entities involved, and cost and revenue streams between the different partners. We have included also at the end of this section two important parts. So one is one contains the key elements and some insights taken from the business models, and the other was a note and a list of technical, non-technical barriers and regulatory restrictions that was, let me say, from practical point of view, taken these results, but are very useful, and we will see at the end something about this. In addition, we have also developed the deployment strategies. That is a guiding report to cities and the public transport operators and the public transport authorities to plan the electrification trip, driving the vision of Assured. The work also in this case were made with several interviews and an heavy impact, making several interaction with the city official, with public transport operator, with authorities, representatives among the assured cities. And the work related to the deployment strategies aims to simplify the process of deployment using the sustainable urban mobility plan methodologies. We have also defined the exploitation strategies to ensure the impact of the project, including measurement methodologies, managing and protecting the intellectual property of the project, and all the generated foreground. So we have identified the exploitation results of the project, the vehicle specific exploitable result, and the strategies. We have also made the same for the fleet management and charging system technologies. We have prioritized and made a risk assessment analysis of fleet management and charging system technologies related to exploitation results. We made the exploitation, we describe the exploitation strategies at partner level, and you can see the scheme we have used on the right of the slide. And we have used an intellectual property management approach and plan analysis to define this in the report. As I said before, these are some output and some points that we have decided to include. And the first is very important from my point of view, is that there is no one solution that is perfect or sound good for each city. And inside each city also, each line has its characteristics and is necessary to make an appropriate analysis, and are all different. The second topic is that the vehicle-related exploitation result going faster than the time schedule within the project, and is a result, let me say. I have included the third topic because should be done a strong effort to improve the competitiveness and overcoming the bottlenecks that we have highlighted in the deliverable. So there is the huge investment cost for vehicle and infrastructure that not all operator are able to sustain. And as usual, if the economic return is not enough, and the passenger or the municipality have not able to pay enough, it's not possible to make the electrification. And this is the first. The second is the interpretation of standard that could be sometimes a bottleneck. There is the local laws and the local regulations per each member state and between the various member states to be standardized as much as possible. And there could be other, but also, for example, the battery prices, that is the LTO battery prices, that is a topic absolutely to deal. Having analyzed all the work performed within the project was really valuable, and should be also underlined that could be important on exploring innovative deployment and business strategies to enlarge the electrification of in the cities, also not only between different vehicles, but also enlarging to different sectors. And and among the different vehicles in any case. Finally, a special thanks to all partners for the collaboration, for the data sharing, and thank you to all for the attention.
Thank you very much, Fabrizio, for this overview on the business models and impacts, exploitation plans. I would like to thank you all for being here and presenting. And I would ask you now to leave the floor and go back to your places. We are going to start the third round of Q&A. So please, everybody, take your phones or your laptops. We have already the first question. But I guess this was already asked before, so it's going to be the following one. No, we are all together. Remember? This is myself. Okay. So let's go to it. Thanks, Aida. What are the advantages of using wireless power transfer for electric vehicles? A, no exposed wires. B, charging convenience. C, power transmission during adverse weather. Or all of the above. You can have now some input here in place. Also, the people that are connected online, please vote. Let's see what's happening with this question. Maybe it's a bit tricky. All of the above. Yes, no. It's quite clear, 70%, all of the above. Correct, yes. That's the correct answer. So maybe we can go to the following question. Yes. Were you aware of the Assured 1.1 interoperability reference? This is yes, no answer. Quite straightforward. Maybe we don't need to think about it very much.
What is good at this time of the day?
Yes, 63%. No, nearly 40%. But now you are aware. That's very good. So maybe we can increase that percentage. Okay, good. 70% yes. Oh, okay. Improving. Better. Good. Good. Next question. There are only two more, so that you know. What do you consider as most valuable result from the Assured use cases and demonstrators? A, developments on standardization leading to interoperable solutions. B, implementing, testing, and comparing fast charging solutions against conventional solutions. Or C, learning more about the impact of the fast charging impact of the fast charging, batteries, TCOs, and so on. So this is actually not, there is no correct answer for this question, but it's interesting to see that there is already a high percentage with a 74% that is direct to the developments on standardization leading to interoperable solutions. Very, very nice. Good. And the last question. In your view, what steps should be taken in the short and medium term to further advance the electrification of urban transport? A, to continue the technological development process and at the same time implemented the interoperability level. B, to decrease the significant investment cost of vehicles and charging infrastructures for a wider electrification in cities. Or C, to create new innovative business models shared between public and private entities involved in local public transport. Last question. Let's see what's going on here. Again, no right, wrong answer, but wow, well, 30%. Everything is quite
balanced.
Quite balanced, yes, I would say, yeah.
And I think it means that what we have achieved within Assured and our partners have presented today, it definitely serves the purposes of our main audience. So cities, operators, happy to see that.
And there is another question from the chat, I think.
Right, that's right. Thanks a lot. Indeed, we had a person, of course, this would be a nice question for the poll as well. Will the slides be available after the event? Yes, of course. We will have them. We will have them on the Assured website, of course. And there's another question which actually is giving me the perfect entry to the roundtable, because there was someone asking what happens with the maintenance costs and the operational costs when I deploy electric buses. This is going to be touched upon the roundtable. So we keep this answer to this question for then. And now just let me announce you that, of course, we have many publications, many results. Part of the main goals of this project is to increase the transferability of our results. So very happy that there is already a big amount of this knowledge base we are going to be able to share with you. But I would like to place the attention on the upcoming Assured Clean Bus report. This is a report that is a collective effort. It's not just an Assured effort. It brings together two fellow projects, the JIVE project and the Clean Bus Europe platform project. These three projects are significantly increasing the attention on clean bus technologies, Assured, of course, from the perspective of electric buses, JIVE from the perspective of fuel cell hydrogen buses. The Clean Bus Europe platform as one of the, let's say, the strategic line of action of the European Commission to support the deployment at a massive scale across Europe. In this report, you will find over 100 cities sharing, let's say, their systems, their examples, how they are transitioning to clean buses, and which are the technologies that are deploying. You will find as well some examples from manufacturers and charging solution suppliers. Of course, not everyone who should be there is there, because otherwise we will have a Bible and not a report. But I would like to invite you definitely to have a look next week. Here. If you register in this QR code, you will be integrated in a registration list and you will receive directly a copy in your inbox. And with that, I think we are ready for the next part, which is the roundtable. I know it's late. We might be hungry. We might be a bit tired. Perhaps our colleagues on the right side under the sun are even a bit, I would need another coffee again. But let's just jump into a very enriching and interesting discussion. And I hope this will keep the spirits high again and will awaken us again a bit. So let's go for it. Arno and our very, very dear speakers, let's come. We will be discussing about, I announced this in the morning, we will be discussing about what Assured has delivered. I think we had a nice overview, thanks to all the project partners on this, what we have achieved during the project, but most importantly, what still lies ahead of us for full electrification. So, here we go. And I give the floor to my colleague Arno.
Thank you, Aida. And no final event, I would say, without a roundtable. So I would be very happy to call on stage the participants in this late morning roundtable. So I wanted to welcome Maurizio Maggiore from the European Commission, RTD, Surveys Transport Unit. Please have a seat on the stage. Professor Maitane Bericibar from the Vrije Universiteit, Brussels, also on the panel. And I would also like to invite Mario Canet from Barcelona, TMB. Welcome, Mario. Sergio Fernandez from a country fellow from Spain, operator of Madrid. And also Gerard Helberg from Vervoerregio Amsterdam. Welcome on stage, and virtually I must also heartily welcome Joachim Kasov. Hi Joachim, we can see you on the monitor downstairs. Welcome, nice to have you. So welcome all, and my name is Arno Kerkhoff, also UITP. I'm leading the bus unit for the association, which is the Knowledge and Innovation Unit. Yeah, it is something you could maybe translate in French. We say it's a creuset, or it is a smeltkroes unit where we combine the bus projects that we are coordinating or participating in for UITP. So let's say the UITP efforts are coordinated in that unit, but we also do lots of association work with the committee. So we have the working bodies, we have the UITP committees, like the bus committee, trolleybus and industry committees that are also exchanging in this unit. And we are simply working a lot on innovations of the buses, so be it electric bus, fuel cell bus, BRT. And we do a lot of international benchmarking. I would say not only in Europe. Well, we will focus on Europe today, but we work a lot also on the international parts of UITP, especially for the e-bus now in India. They seem to be scaling up quickly. So this shortly on the bus side. I will maybe join you to be on the same seat, and I hope that the camera work will follow. Yes, very good. So we thought it was maybe nice on the round table to try to wrap up a bit on what had been presented this morning. We thought we could probably use maybe some end user perspective to see what has been developed in the Assured project is of use in let's say day-to-day work in operations. For that we are very happy that we have such a distinguished panel with us. Maybe the first start I would like to focus a bit on the research, specifically on the research and innovation aspects of the Assured project, with a more general question. Because during this morning's session, so we have heard in, let's say, these 3 modules on the outputs, the results of the Assured project, and the main learnings and the results were presented. And we also maybe making the connection earlier this morning with the keynote speech from Patrick Mercier. Patrick, you mentioned also the organization of the research work in the Commission around the new partnerships. So I remember you mentioned the CCAM on the, let's say, connected and automated mobility, but also the 2.0 partnership. And yeah, this brings me to the first question to the European Commission, who is represented here by Mauricio. And my question would be, which aspects would you highlight when you have listened to this morning's presentation as most relevant from your perspective, and also in the light of the future research program of the Commission? And then I will maybe ask my colleague to... there's a, you can share the mic. Oh, great.
Thank you. There's plenty of interesting results, but I think the interoperability is for the end users the most important one, because let's say it gives a level playing field with the competition and the certainty that there's no wasted investment, that you can reuse infrastructure even if you decide to have another supplier of buses involved later on. So that's very important. And overall, I think there were the question just on the slide. Overall, the issue is reducing the cost to make the TCO even better. Of course, the simulation already showed that basically there is an advantage, but maybe we will listen how the reality is from the operator point of view, and maybe from there any idea for let's say a further focus in the future. For sure, there are also some technical results which are interesting, like the inductive charging. I had inductive charging projects, and the results were something like 50 kilowatt maximum, so it's doubled, and the efficiency was 80–85%, and now it's 95. So of course there are other issues, but of course the basic thing is make it affordable. And of course, the other point maybe is the cooperation that allowed this standardization and interoperability to take place. That of course, when you have a lot of the actors involved, it's easier.
Thank you very much. So we take stock of that. So interoperability, TCO cost reduction, standardization, continuous standardization effort. Maybe, of course, we are closing with this final event, the Assured project. So it will be the end of a long-running research project. If we look to the future, let's say for the future research program, could you already see room for, let's say, in the architecture of this program for other areas of follow-up research, or is it still too early?
Well, for sure, one thing which is happening and will happen is the expansion towards other heavy-duty segments. That's very important because our colleagues from the policy directorates are pushing for decarbonizing the heavy duty sector as a priority. And a lot of the experience done here will certainly be extendable there and reused. At the same time, as Patrick said in the morning, we are looking at BRT applications. Mm-hmm. So I would say even more demanding applications for public transport. And at the same time, we are trying to approach the cost issue in projects looking at the component level. Mm-hmm. So for instance, we have several projects either just selected because we had the first call or being presented in April, or we're preparing the next calls, where we will be looking at for instance, the fast charging, to try and bring down cost and increase efficiency, and at the same time at the component level for the, let's say, powertrain, and particularly the battery, because I mean, we mentioned 2 partnerships, but there's a complete partnership on batteries, where we try to establish to support the establishment of a European battery industry. At the moment, we have battery production in Europe because, of course, due also to the difficulty of shipping and other things, we have local, it's important to have local supply chain. But of course, we would like also to have own technology. Yeah,
absolutely. Now, thank you. Yeah, indeed. So we will also take stock of this battery, let's say, partnership for the future calls. And yeah, talking about innovation and say research aspects of the project, we have, of course, also the academic world. So with today, yeah, representation by Professor Maitane, you are leading the Battery Innovation Center at the VUB, and we heard this morning that the battery is was and is still a very critical component of the electric vehicle. Assured was on the fast charging, so it's high power fast charging, also to gain on the time, thinking about the operations time for the bus operations. But we all know that this brings quite a lot of stress, right, on the battery component as such. So maybe my question for you would be, looking into the research field in the academic world, what are the solutions that are now under research to overcome fast charging impact on batteries?
Yeah, thank you for the question. Actually, first of all, I would like to give a little bit of an overview of what's going on together with the Commission, and thanks for the Commission on the ecosystem that has been now launched, or some years ago now, in which, for example, there is coordination and support action that it's called the Battery 2030 Plus initiative, which leads all the research that is going on low TRL level. And then this is directly connected to other platforms in which we have Batteries Europe, as well managed and initiated by the Commission, and the partnership that Patrick was introducing this morning on Bat4EU. And then at the end, linking, let's say, these two partnerships or platforms are linking the academic or very low TRL level with the industry, and then we have the European Battery Alliance for deploying all these research insights from academia into the industry. But yeah, I think it's extremely important to have this platform, to have this ecosystem, because everything is very much related. What's going on at materials level, what's going on at cell level, what's going on at module, pack, and then, of course, depending on the application, everything changes. So it's important to have a connection, an interlink, and a smooth communication between all the different aspects on the battery world. And yeah, for fast charging, I would say that all parts are quite important. This is something that is always tackled on both, on technologies that now are on the road, or they are like coming advanced lithium ion, so the same kind of technology but newer generation, but also for novel technologies like, for example, solid state batteries. The fast charging is quite tackled by inclusion of sensors, inclusion of self-healing properties, and understanding as well how to transfer all this knowledge to novel coming technologies like, for example, solid state.
Yes. Yes, thank you very much, Maitane, and it's incredible to discover this entire research world, I would say, around the batteries and the battery chemistry, and also very exciting to look ahead, to look forward how the European Union is reinforcing with the battery partnership also its capacity to develop knowledge and research in that domain. Assured has been looking specifically when talking about batteries on the impact of battery aging and on aspects of the grid stability. I think that during the lifetime of Assured, it is also a long time that at the same time the battery technology on the market has of course developed enormously in that time. And when you would look from an operator's perspective, and the operators are with us today, of course they are looking for you can say small batteries, for light batteries with maybe unlimited range for operations, and for cheap batteries. And today we have to admit that they are still they are heavy, they are big, they are expensive, and short range. So there's sort of shortcoming. And my second question, maybe Maitane, for you, will be for the features on the battery. So what are the features that we can find in the new battery technologies? What's there yet to come? What can we expect? Can we expect, for instance, smaller batteries in the short future with higher energy densities? Also at affordable cost prices, and what are also the risks maybe that we could imagine with the super batteries for operators? Could you have maybe some maybe reflections on that?
Yes, of course. Well, one of the main topics as well to tackle in batteries is how to increase the energy density, so that to make lighter and smaller batteries. This is something that is being tackled with new technologies, like, for example, solid state. However, still we are not at a point that we can manufacture this type of batteries. We are still on this learning procedure. But in any case, as I was saying, there are also a lot of research actions that are being done in advanced lithium-ion technology, in which we can improve it, and we can improve the thermal management system. For example, when we are going to go for fast charging, then we can have a smart thermal management system that can activate the cooling system, so that the impact on the fast charging will be lower. And as well, a novel introduction of, for example, sensors. This is something that is quite tackled now. We are part of a Spartacus project now, developing this kind of sensors for understanding and extending the lifetime of the batteries, as well as self-curative batteries. This is also something that now we are understanding very well at VUB by coordinating a project, Bat4Ever project, in which, of course, this is one of the aims, is to tackle fast charging with this.
Yes, thank you, Maitane. I'm sure we will, of course, all stay tuned to to follow the topics with high interest for also the let's say the applications in the operations. So thank you very much. So talking about batteries and manufacturers, I think my colleague Aida mentioned it in the morning. There is always with European projects some magic in the air when the project is working well, and I think we could conclude that in Assured definitely we had this unique collaboration spirit in the project with the different chargers, the different eBus brands, and in the end also with the industries, competitive industries on the market, I would say, that are collaborating together in the project. So maybe my next question would be more for the European Commission, maybe to you, Maurizio. As Assured is a great example of on how cooperation also amongst industry competitors can in the end bring forward the European research and innovation for the benefit of the sector. How is this valued by the European Commission? How do you see this?
Yes, I think we have different situations. In a case like this, where the end result is really standardization and so on, I think that's invaluable. We need more of that, but of course, in some areas we are maybe early in the process, and sometimes there's not always the same level of cooperation when the technology is still being developed. So that can change from case to case and from application to application. At the same time, in other areas, I think we have come a little bit to prefer a bit more competition between the projects rather than huge projects with the kind of a conservative approach. Also because being competitors, nobody wants to share the best in a European project. So we have seen some projects having problems of this, and therefore in some areas I think competition exactly to bring forward more advanced solutions it's good. So it's really on a case-by-case basis.
Yeah, thank you very much, Maurizio, for this answer. And I think for the future we will, of course, in the upcoming projects, not see if the increased competition with what you mentioned, more but smaller research project will also help in the end the sector to make progress.
Yeah, and maybe of course the involvement of end users is another area where we have more and more in the future. Because of, for instance, of the missions that were mentioned in the morning, where really if you wanted the concept of end user is extended even further. It's not just the operator, but also the city that basically needs a solution for transport as a whole, and therefore there was interesting mention, I think, in the last presentation about this fact of sharing some of the infrastructure. For instance, that can only be when you have everybody around the table. So I think the missions, for instance, will be something we didn't have before, where this kind of cooperation can go even wider.
Yes, absolutely, and indeed we have the luck to have a city, let's say, on the panel with Amsterdam City. I would say Amsterdam Metropole, I must say. So we will have later on in the discussion also some opportunities to hear, I would say, the point of view from Amsterdam Metropole as end user, I would say, of electrification. So indeed, wide matrix, diversified stakeholders for the end user perspective. Which brings me maybe to the next set of questions, more maybe focused on the technology, because we have seen the technology roadmap. I believe it was the TNO presenting some of the milestones, and also earlier the VTT. If we look to the technology roadmap, for instance, for electric buses, we see today on the market there are battery buses. We have also fuel cell hydrogen buses, which are clean buses, and also trolley buses, which are making an innovation, with a second career in Europe with the Emotion charging. But also we have many different technologies for the charging, whether it's conductive charging, inductive charging, or we hear a lot about. My question would be maybe for Barcelona, because we know Barcelona so well in UITP, of course, as a member, but also for the numerous innovation projects that TMB is involved with. And maybe Mario, you participated for TMB and your team in the project. And as an operator, I would be very curious to know what is your view on the perspectives of this inductive charging technology. Is this something that is on the radar in Barcelona, or how do you see this? And maybe a second question is on the evolution of the charging technologies for other applications. So we talked a lot about buses, but an application about e-trucks or e-vans in Barcelona. So wireless charging and the other applications. What is the, let's say, the point of view from Barcelona?
Okay, thank you. My point of view is that inductive charging has a very big road to improve, and will be a very good solution for small cars. But in this moment, the power of the pickup is not enough to arrive up to this 500 kilowatt-hour that we are charging in a bus or a really big vehicle. We have studied this possibility, but we need more than one pickup under the bus, and the complexity of the infrastructure becomes very, very big. And the efficiency could be improved. Okay, I think that probably for our kind of application, the conductive solutions are better now. And I'm sure that the future of this kind of technology in the city is arrived to share this kind of infrastructure for more than one model of transport, not only for bus, not only for one operator, as is now in Barcelona. I think that the future of these infrastructures will be usable if we can share this infrastructure with other operators or other kind of transport vehicles of garbage trucks and other users that then can use this infrastructure in the hours where the bus is not running, and share the cost of the infrastructure and the cost of the power connection. Yeah,
thank you, Mario. Very interesting to hear that you have plans, or that you are considering these. I would say these opportunities in the end for maximization of infrastructure in your city. I know that your neighbor actually from Madrid, operated from Madrid, Sergio, that you are testing wireless contact buses. Right, I heard through the bus committee that you have an inductive bus line. Is this a technology that you are, I would say, simply testing on a trial line in Madrid, or is this a roadmap? Is this a direction where you might develop the technology, e-bus technology, in your city?
Yes, indeed. Well, first of all, I would like to remark that EMT Madrid is not an assured partner, but part of its public transport user group. And then from this inductive charging thing, yes, we do have a bus line running on a commercial basis since the very beginning of 2018. Charges by induction is the bus line number 76. And this was a sort of, well, actually, it was more a research project rather than a proper business line to develop in the close future. We have 5 buses, and I do agree with Mario that there is still kind of some path ahead before getting it as a real solution, especially because I think that as you don't have any physical interface between the vehicle and the charging infrastructure, it's very good whenever you are able to combine it with probably other services, such as the refuse, the garbage collection services, or any other services. It's running well, But now, today, at EMT Madrid, we are more betting on electrification as such, either by, well, basically by ACDs, so we are betting on inverted pantographs. And this is also really very relevant for us because... Yeah. Is working now?
Yeah. You can hear it again. Yeah.
Because as we are quite a big company, we have 2,100 buses. And we have very ambitious... Okay. Thank you.
Maybe the
and we have quite an ambitious plans in terms of upscaling electrification. We need to look very closely to all the achievements such as Assured Project ones in terms of especially standardization and interoperability.
Yeah, thank you. Thank you, Sergio, and also thank you for reminding that you are not a partner in the project, but nonetheless active knowledge sharing in the user group. And also, by the way, congratulations! I think with your anniversary, right, of 75 years of existence of EMT. So we are of course
75 years.
Yeah,
so
wonderful.
Far.
It's a senior operator. So we are celebrating that also, of course, in the UITP. But thank you, Sergio, for your contribution. And yeah, which leads me to the next question, and maybe more a general question for the operators. And I would also like to involve the online participant here from Osnabrück, far away. And it would be on the outcomes, let's say the concrete assured outcomes, to understand how these outcomes contributed or do contribute to the easing of your bus operations. So as a bus operator, so I would like to ask, maybe to start, Joachim, can you highlight maybe some concrete project achievements from Assured that have supported your daily bus operations?
Yes, I would very much like to do this. Thank you for having us. Thank you for being part of the Assured group. Up till now, we have only one fleet supplier in Osnabrück, which is VDL, which by instance also is one of the Assured partners. And being the only supplier is nice for the manufacturer, but it creates a lack of diversity, of course, for the operator. So the Assured project enabled us to demonstrate in practice that it's actually possible to operate different bus types on one line with different chargers. And that was really important for us to know and to prove that it works in practice. We also had a really good experience when we connected the Assured charging station to the power bank, which Ida told earlier about. That was really practical for us. And personally, for me, I'm not a technician. I got a lot of know-how, especially from the colleagues from IDIADA when they were here in Osnabrück, showing and explaining everything to someone who is not technical orientated. So that was a personal learning for me as well.
Yes, thank you, Joachim, live from Osnabrück. And we heard actually last week by your colleague from the VDV, so the German Public Transport Association, Mr. Reitmeier. He was busy in another webinar. He was sharing actually some very impressive support scheme from Germany to support the sector to electrify. I remember 1.25 billion euros for the next 5 years, and with a target of let's say 5,000 electric buses in Germany until 2025, of which 800 fuel cells, I understood. So very impressive numbers. And we know that in Osnabrück you have started already the rollout of electrification, but you are aiming to have a full fleet electrified in 2025 as well. And this is of course very short ahead, so we are talking about 2 years from here. My question would be for you, what are maybe the main lessons learned that you would like to share with other bus operators, but who are starting now, and so who are, let's say, at the early deployment phase. So what would you like, or what could you share with them?
Well, now I could start to talk for an hour and a half at least without stopping, but to make it really brief, the first important thing is, and that's also something we've learned in Assured, there's not the one-fits-all solution. There are different types of charging, there are different types of batteries, different types of buses. So therefore, you should think about what you need in your company and in your operation area, what requirements you have for an electric buses. And this preliminary work has to be done really thoroughly, and probably also have to be taken a little bit more time than you first think, because we all know that we always want to have things really, really fast. But when you do this preliminary work thoroughly, then it will be a success. And after that, it's like they say, just do it and just go ahead and work on it, and don't be afraid to make mistakes.
Don't be afraid to make mistakes. Yeah, thanks a lot. Just do it, and well, we will of course also broadcast this message to the wider audience, and especially the cities in Europe that still are starting up. And of course, we will, if needed, bring them in contact with Osnabrück. And of course, we have no time to develop this in the roundtable here. But thanks a lot for sharing this, these insights and these suggestions. Another part, let's say maybe less technical but more economical, is on the TCO part. So we have heard in the different presentations and also simulations, again, I would say, of the high concerns on the investment cost of the electric vehicles, high upfront cost, capex, and then comes of course always the win back with the better operations cost. We hear a lot in other forums as well from operators that the maintenance cost, for instance, is claimed to be lower than for instance diesel buses. Electricity energy consumption is lower, but it would maybe be interesting to hear. And then I'm maybe looking for you, Mario, in Barcelona, in TMB. Could you give maybe some set points or references with the experiences gained so far? If this is true, that indeed operations costs are structurally lower than the diesel buses, and what are for you as operator the main benefits of operating electric buses?
Okay, when Assured, can you hear me? Yeah. When Assured began, we studied the TCO in this moment, and the cost was more or less the same that with diesel bus. If you divide the cost of the infrastructure on the street and the chargers on depot, etc., and the cost of the batteries. Well, TMB launched tenders to buy TMB buses and for other operators, and we are always continuously launching tenders and receiving offers from the manufacturers. And the tendency now is that all the manufacturers give 15 years warranty for the batteries. Okay.
15 years.
15 years, complete life. Okay. You can forget the battery cost for all the life of the vehicle. And if you center it only in the cost of the maintenance of body and chassis, that is as other kind of vehicles, and the powertrain, motor, and inverter has not maintenance. Following our figures, in this moment, the cost of one solo bus, electric solo bus in 15 years is around 115,000 euros less than one diesel.
150,000 euros.
Because you can forget the battery cost, absolutely.
Thank you very much. I'm not sure if we can share, let's say, all the price quotations in the public domain, but I think it's at least interesting to hear that in your TCO calculation, this let's say calculation is looking like you just described. And we also take note that the industry on the market, the manufacturers are apparently adopting their offers to give this additional warranties for covering the battery warranties over the lifetime of the bus. And of course, this is important for the capital expenditures, but there are also the expenditures to make on the depots. On the depot side, we might sometimes forget about it, but we heard in Madrid, for an example, you have extremely ambitious plan for transitioning your depots to electrified depots, which brings me to a question to Sergio for EMT. So your Elipia depot with 300 buses is going to be electrified as bus depot. Seems titanic as project, but maybe you could share with us what are the main tasks that you are working on today for this project.
Yes, indeed. At EMT, we recently approved our new strategic plan up to 2025, which includes a very ambitious target in terms of electrification. We need to reach 25% of our fleet fully electrified by 2025 and a third by 2027. It's impossible to cope with this unless you have the proper infrastructure, and that includes the bus depots. So beyond the installation of charging points today in some of our bus depots, we have decided to renew completely one of the oldest ones. This is La Elipa. It was closed 2 weeks ago, actually. We have had to make a huge effort in reallocating all the operations, which includes 1,200 people, 315 buses to other bus depots in the meantime. So it will become one of the, I don't know, avant-garde, I guess. I'm quite excited about this project, bus depots, because it will be fully roofed with a total capacity of 318 buses, 20 of them articulated. It will have inverted pantographs, charging infrastructure. I think the surface reaches 40,000 square meters. The building itself, the facility, it's a nearly zero emissions building. So it will have photovoltaic panels, photocatalytic roof to reduce NOx pollution. Now we are in the process also, it's been a long process also to depollute or decontaminate the soil after such a long time being in operation on a conventional basis. And it implies a huge investment, 115 million euro. So that is related to this maybe high upfront costs that operators need to face. I want to take advantage of the presence of the European Commission here because European funding may help a lot in this process. We have been awarded with 100 million euro in the Next Generation funds recently for different initiatives, including the installation of inverted pantographs, so that helps a lot. Be ready to apply for the funding. It's something that we have even recently created a specific European funds department just to be attentive to all these. And yes, it's a real challenge. So we hopefully, I guess by the end of 2024, it will be fully operational and you will be most welcome to come to Madrid to visit it.
Okay, well noted. We take down this invitation because I think you make us very excited on what is happening in Madrid. I think you also Sergio, you worded very well the complete transformative dimension of such a project, where indeed you are in the end adding complete new departments, new competences, new skills into the company to face the transformation to electric depot. I think that your note to the European Commission was certainly also well taken. I saw that some notes were were taken. I also know that depending on the member state, so you are from Spain, in Germany, there are also national support schemes for infrastructure. Depot adaptations, I heard, will be in Germany supported by 40% of investment cost. So I'm quite sure. Unfortunately, we cannot develop too much on the roundtable on the funding exchange, but there's lots of knowledge there as well to gain. And maybe we should make an interconnection with the Clean Bus Europe platform, another project where we can share this kind of also funding schemes, experiences from other member states. Thanks a lot for this insight from Madrid. And this brings me almost to the end to the roundtable, but not without, of course, giving the floor to Amsterdam, because Gerard Helburg, you are with us. You are not an operator, but you are the public transport authority from Amsterdam Metropole region. Actually, so contracting the operations to the private market. so the operators are not with us in the panel, but I think it is interesting to know for the audience that in the Netherlands, you have an extremely competitive organization of public transportation, where the operations are put into concessions, and where the concessions are put to tender in the market. And you are supervising that as a public transport authority, but also we know that the Netherlands are leading actually in Europe when it comes to the number of electric buses. I saw in the latest countings that it's still #1 country in terms of deployment. This brings me a bit to the question on the other end users. Maurizio, you also mentioned that beside operators, authorities, there are also the energy providers, the grid owners. And it would be interesting to hear from a PTA perspective how a PTA as Vervoerregio Amsterdam support or can support a fair and let's say fair and just access to the power supply for all the operators. And are there any reflections inside the Vervoerregio on a cooperation or maybe a policy work to handle that?
Well, thank you, Arno, for the kind words. When we started this transition for these zero-emission buses, we already came into in contact with our power grid companies, and they stated, well, okay. Before tendering out, we started addressing our issues with our power grid companies and with our municipalities, and saying, okay, we need power on that connection. It's going to take this amount of power, but also this amount of land usage. Then our power grid companies, almost everyone said, well, it's feasible for this specific demand, but take notice, our capacity is almost done here. And then we thought, okay, so we can introduce a zero-emission bus system, which will be done by 2025, just making a little bit of advertising. But we have a lot of other types of mobilities which also needs to be become clean, zero emission. Mm-hmm. We calculated that power for our bus system is roughly 16% of the total clean energy you need to have a clean mobility system. But then again, the mobility system only takes 9% of the entire energy transition part. So we can arrange the 16% of the 9%, but then the other 90% or something doesn't have clean renewable power. And so we have a problem with power production, but also with transport that power. And then this interoperability thing came along, and we decided, okay, we actually need not only to expand the power grid as we have it. A recent calculation stated it almost needs to be 4 times a bigger power grid in our region to have a mobility system which is clean. But also we need to share our connections. We need to share our pantographs, we need to share our power cabinets, we need to share our power connections. We just did not know how until we came across Assured. Now we see that we are drafting a framework to share the power between the different users we have. Not only the bus, but also other bus operators, but also emergency services, logistical partners, garbage trucks. Every mobility partner from a which can be made arrangement with. So that excludes personal of private persons actually, but it should be a way to share the power that you have and share the connections that you have on the power grid, just to make sure that we do not stop this energy transition, but just accelerate it. And I just completely forgot your second question, actually.
Second question was still to come, but I was just listening to you because it's a very interesting experience that you are sharing with us from Amsterdam PTA. Also because we of course know that you have many concessions that are already electrified, if I can put it like that, with the 24 hours services around Schiphol, Amsteland. You continue with also the next concessions that you put in the market to in fact to require from the market that these will be offered by electric buses. So my second question would be more maybe economical point of view. How, as a PTA, do you ensure that the electrification or let's say the zero emission transition is affordable for the market and thus a success? Do you have maybe a magic ingredient to to share with us?
Now, luckily we see that operating a zero-emission system is cheaper than a diesel system, and luckily my colleagues here, or PTOs, confirmed it. We just made calculations, TCOs, business cases, and then we saw that operating a zero-emission system is actually cheaper. We also saw it during the COVID pandemic. We saw PTOs using the electric buses on different routes, because they decreased the public service timetable, and then they increased they just used all the electric buses that they had, because power is cheaper actually than diesel. So we had a pre-calculation confirmation, but also we saw it in practice during the COVID pandemic. So for us it's fairly easy, because we are very convinced that it's economic beneficial for both parties. That's why we actually start with developing charging infrastructure locations way before we start the tender. So we actually know that there's enough power on that location. I think we started 3 years before publishing our tender. We're thinking, okay, how can we achieve this zero-emission transition? Knowing that you have an implementation phase of 1.5 years, but still you need to be prepared well before that date. So,
thank you very much, Gerard, and for also the complementary, I would say, point of view in the roundtable from not from an operator but from a public transport authority perspective. Very useful. Thanks a lot. I'm looking to the master of ceremony, and maybe it is time really to wrap up, right? Because the lunch is waiting, and all kind of time issues are now getting urgent. So thanks a lot. All maybe one I would say as a closure, maybe nice question as a key takeaway from the operators in the panel, because we can now conclude that having achieved this interoperability referential, this interoperability standard for e-vehicle charging is in the pocket, so we can work with that in the market. But what is from your perspective the next challenge ahead to ensure the electrification uptake further, or maybe just in terms of wish list, what would be your wish to have next? And maybe if you could formulate it in one statement, and starting with Joachim, because you are online, could you make your contribution in the concluding round? So
yes.
One last wish from Osnabrück.
The next thing we are working on is an automatic or even autonomous depot. Of course, everything costs money. We've been talking about this earlier on today. So we are looking how the funding is going to go, and then we will see how the technique is going to go.
Thank you very much, Joachim. So well noted. Autonomous docking and let's say automatized depot operations. Well noted. Then maybe from Germany to Spain. Any wishes left in Barcelona, Mario?
For me, it's to find. I think that the elliptic was in this line, but it's very important to find ways to share infrastructures and connection. For example, in our case, for me, it's very interesting. We are using the grid, the metro grid, to charge vehicles in the night when the nights don't run, and we can use the same infrastructure. And we must, I think that we must work on this line.
Thanks a lot. And indeed, we heard about Elliptic in the morning, and we take due note of that as well. So charging infrastructure shared, mobility hubs, charging hubs, as a number. High number on the wish list for the next years to come. Thank you, Mario. And same question, and then it's really the last question. So to close down the roundtable would be from you, Sergio.
I do agree with the different statements before. Maybe I would say that it's a combination of what it was stated in one of the last slides. It's about moving forward in terms of standardization and interoperability. It's about decreasing the upfront costs. It's about fostering public-private cooperation. I think if we have all these three elements together, we will go really we will reach the point in which we want to be. Yeah.
Thank you. Thank you all. Thank you, Sergio. Thank you all, and also for all contributors to the roundtable, European Commission, the Vrije Universiteit Brussels, and the Vervoerregio Amsterdam. Thanks a lot for sharing, I would say, some insights and stock taking of this first part of the final event. I will give over the microphone to Maitane. Thank you very much.
First of all, indeed.
Yes, thank you. It was a very nice roundtable that I could have the chance to be with all of you. But now we are, of course, in the last part, in the closure of this plenary session. Aida?
Unfortunately, reaching the end of our journey this morning. Thank you very much to the panel. Thank you everyone here and online for bearing with a delay of 1 hour, which was, I have to be honest, I expected delay, but not 1 hour. So I hope the discussion was rich enough and valuable enough for each of you. In my case, I would have them longer, but I know we need now to make a break. We need to go for the lunch break, but not without thanking you again. And just a couple of informations we wanted to share. So the first one is about the parallel sessions that are going to take place now after the lunch break. We will start at 3. We will make it easier, so just 30 minutes of delay for the start of the parallel sessions. Just a mention for you here in the room, we will stay here for the parallel session number 2 on full electrification with shared infrastructure. So we gather here after the lunch break. We will meet for the standardization and interoperability session with VTT and IDIADA and the Classic Lounge, which is that glass space over there. And for the third session with our colleagues from VUB and TNO, we will meet downstairs at the Minerva room. When you enter, you remember you had on the right side the welcome desk, just on that side. That's the room distribution, but I think we deserve to close also the event in the proper way. Maitane.
Thank you very much. I just want to warmly thank all the participants of the project, of course, the support from the Commission so that this could be achieved, and everybody that today joined us here and online. Thank you very much.
Thank you, everyone. Time for lunch. Nice discussions, further enjoying, but in a more relaxed way. See you in 1 hour.